Hello guys, welcome to Sleepumentary. Tonight we drift into the vast silence of the cosmos together, where one small visitor from the stars has ignited headlines, fear and wonder. Its name is 3i Atlas. Some call it a comet, some whisper it might be a probe, and others dismiss it as nothing but a rock carried by chance. But one truth stands clear: it has become a cosmic distraction. In a world already buzzing with news alerts, viral posts and sensational claims, the arrival of an interstellar object becomes irresistible. Social media thrives on it. Dramatic thumbnails warn of apocalypse, breathless threads speak of alien probes gliding silently through our skies. And yet while attention is drawn to the spectacle of this distant traveller, the very real dangers, the ones that could erase everything we know, pass almost unnoticed. Genuine apocalyptic threats do not always come with fireworks or a chorus of hashtags. They may slip past quietly unheralded without a single headline. A rock no bigger than a city block could fall unseen from the heavens and in one blinding instant turn everything our cities, our streets, even our reality itself into ash. That is the uneasy truth. Humanity's greatest dangers may be the ones we never see coming. But here in this space between curiosity and calm, we take those fears and transform them. This is not a channel of panic, this is a channel of perspective. Science for Sleep once called it the art of turning terrifying cosmic ideas into gentle bedtime reflections, and that spirit lives here too. Because sometimes to find peace we must stare into the abyss and understand it. So before we begin our journey tonight, I'll extend a small invitation. If you enjoy travelling with me into these mysteries across time, across stars, feel free to subscribe, leave a like or drop a comment. But only if it feels natural. There is no rush. This is not a race. Instead, imagine it as a gathering, a quiet campfire under the stars where curious dreamers sit side by side. And if you feel like sharing, let us know where in the world you're listening from and what time it is there. Maybe even the dream that last lingered with you when you woke. You'd be surprised how many people around the world have dreamt of falling stars, burning skies, or oceans that rise to swallow the land. To share them is to realize we are never entirely alone in our imagination. Picture it now, millions preparing for sleep, in bright cities where the sky is veiled in orange haze, and in remote deserts where the Milky Way burns in impossible detail. Some tuck themselves into small apartments, others lie beneath canvas tents pitched on cool soil. And yet all of us, no matter where we rest, are linked by the same thread of vulnerability. Above us, vast, incomprehensible forces sweep and churn, forces that could erase us in silence, yet also cradle us in wonder. So tonight, as you sink into your pillow, let's follow the path of 3i Atlas. Not as a herald of doom, but as a mirror held up to ourselves. We'll explore the truth, the fear and the beauty hidden in its wake. For the story begins not with malice or conspiracy, but with something older. Our human habit of seeing patterns, of filling the darkness with meaning, and sometimes with fear. When you close your eyes at night, what is it that lingers on the edge of your thoughts? For many it is not only the memories of the day, but the strange, persistent fascination with endings. Humanity has always been haunted by the idea of the world's last chapter. Extinction-level threats, whether real or imagined, echo in our myths, in our art, and even in the conversations whispered just before sleep. Long before telescopes or satellites, our ancestors looked to the night sky and saw more than stars. A blazing comet was not merely ice and dust, it was an omen. In Babylon, comets foretold the deaths of kings. In Europe, Halley's comet was blamed for wars and plagues. In China, the sudden streak of light was thought to signal dynastic change, as if the heavens themselves signed the decree. Each culture painted the same truth. Endings frighten us, but they also captivate us. Even today, when we know more than ever about the mechanics of the cosmos, that ancient instinct lingers. We talk about asteroid strikes over dinner, share memes about supervolcanoes and trade theories of black holes that might consume us without warning. There is something strangely comforting about imagining the end as though by naming it we gain a kind of control. Psychologists suggest it is the same reason people gather around ghost stories or disaster films, to face fear in a safe place, to explore the unimaginable without being consumed by it. And so our myths evolve. Where once it was fiery serpents in the sky, now it is rogue artificial intelligence, runaway climate collapse, or an interstellar visitor like 3i Atlas. Each threat is wrapped in a story we tell ourselves about fragility, about limits, about what it means to live at the mercy of forces larger than we are. Think of late-night conversations, perhaps you've had one. The lights dim, the world grows quiet, and someone asks, "How do you think it will end?" A meteor, a virus, humanity itself tearing the Earth apart? The answers range from hilarious to absurd, but the question itself is universal. We are the only species, as far as we know, that not only fears death, but also imagines the death of everything. It is both a burden and a strange gift. There is even humour woven into this darkness. We laugh about apocalypse bunkers, about building rocket ships to Mars, about the irony that cockroaches might inherit the Earth when we are gone. These jokes are not just laughter, they are shields. They soften the terror and remind us that the end, however it comes, is not here yet. Tonight we are alive, breathing, curious, and so when we turn our eyes to 3i, Atlas, we project these ancient dreams onto it. Is it a messenger of doom, a sign from beyond, or just another rock passing silently through the solar system? The truth may be simple, but the stories we weave around it reveal more about us than about the object itself. Because in the end, what fascinates us is not just the possibility of destruction, but the reminder of how fragile, and therefore how precious our world truly is. There is a question that lingers every time a blazing streak crosses the night sky. Why do we as a species so often tell stories of doom? The comet is nothing more than rock and ice, yet throughout history it has carried the weight of prophecy, judgment, and dread. The answer lies not in the heavens, but in the deep folds of the human mind. Fear, after all, is a survival tool. Our ancestors lived in a world of sudden storms, prowling predators, and unpredictable harvests. To be alert was to live another day. When the night sky shifted, when a new unfamiliar light appeared, it triggered the same instinct that once saved a hunter from a rustle in the grass. Better to overreact than to be caught unprepared, and so fear became story. A comet wasn't simply a light, it was a warning. Ancient chronicles are filled with such interpretations. In 44 BCE, the death of Julius Caesar was marked by the appearance of a comet that shone for 7 days. The Romans declared it a sign of Caesar's soul ascending to the gods. To others, it was an omen of chaos. During the Norman conquest of England in 1066, Halley's comet appeared in the sky, and chroniclers described it as a long-haired star, blazing over the battlefield, a fiery herald of king's downfall. The Chinese meticulous sky watchers recorded comets as broom stars sweeping misfortune across the land. Everywhere, the same instinct translates uncertainty into meaning. But it is not only fear that drives these stories, it is also the hunger for narrative. Humans are pattern-seeking creatures. Where randomness exists, we sketch lines and connections. A comet arrives, a war begins, a king dies, and suddenly the pieces seem to fit. The story comforts us because chaos without reason is harder to bear than terror with meaning. Even in catastrophe, we want to believe there is purpose, and the habit has not left us. In modern times, we still attach apocalyptic meaning to celestial visitors. When Oumuamua passed through the solar system in 2017, it became the subject of fevered speculation. Was it a probe, a shard of alien technology? When 3i Atlas appeared, social media declared it a Death Star, a messenger, even a weapon. Despite centuries of science, the ancient reflex remains: we take the unknown and cast it as an omen. Psychologists tell us that imagining endings gives us a strange sense of control. If we can name the threat, if we can dress it in myth, then we are no longer helpless before it. It is not chaos, it is destiny. The comet is not random, it is a sign. Perhaps this is why apocalyptic movies draw such vast audiences. We are afraid, yes, but we are also curious. Doom becomes a canvas for exploring our fears, our resilience, even our hopes. And yet beneath the stories of fire and ruin, another truth waits quietly. Each comet that has passed has left us still standing, still alive, still telling tales beneath the same stars. The sky brings fear, but it also brings awe. And maybe in the end, our stories of doom are less about endings and more about reminders that life, fragile as it is, must be treasured precisely because it could be taken away. Now pause for a moment and imagine the world as it is in this very second. Somewhere someone is just beginning their day rushing to catch a train. Somewhere else the sun has slipped beneath the horizon and the sky has become a dome of stars. And scattered across continents and coastlines, millions prepare for rest. In crowded cities, the glow of neon signs seeps through half-closed curtains. Apartment windows flicker with the blue light of televisions. Children curl beneath blankets, the hum of traffic their lullaby. For them, the stars are distant, hidden behind a veil of haze and concrete, yet the curiosity remains the same ancient wonder that once made shepherds pause in dark fields to watch the sky blaze with comets. Far away in deserts and mountains, the story feels different. There the night is alive with silence and clarity. The Milky Way stretches in ribbons sharp enough to take the breath away. A family in a tent might trace the patterns of constellations pointing at a faint streak of light and wonder what it means. In these quiet places, 3i Atlas is not an abstract headline. It is something you can truly see, a reminder that the universe is not a distant theory but a vast reality pressing down above us. Across oceans, on small islands where waves lap at the shore, people lie in hammocks rocked gently by the sea breeze, their eyes lifting to the same stars. In villages tucked among forests where electricity comes and goes, elders tell stories to children before sleep. Stories of fire falling from the sky, of serpents made of light, of endings and beginnings. In skyscrapers, students scroll through their phones, watching animations of asteroids striking Earth, half terrified, half entertained, before setting their devices down on the nightstand. Different languages, different cultures, different rituals, but one shared thread: vulnerability. No matter where we are, no matter how advanced our cities or how humble our shelters, we live beneath the same sky. The same streak of light that startles a farmer in Mongolia can be seen by a sailor on the Mediterranean, a child in Brazil, or a night shift worker in New York. The comet does not belong to one nation, one culture, or one age. It belongs to all of us, equally fragile beneath the dome of stars. And perhaps that is why the story of 3i Atlas feels like a global bedtime story. It is told in whispers, in headlines, in theories shared at midnight. Some tell it with fear, others with awe, but all of us listen. Tonight, as you close your eyes, know that somewhere across the world someone else is doing the same, drifting into dreams with the same questions lingering. What is out there? What does it mean, and what does it remind us about ourselves? The human mind is a remarkable storyteller. Give it a shadow and it will invent a monster. Give it a flicker of light in the night sky and it will shape an omen. This is our gift and our curse, the ability to weave meaning into every gap, to turn silence into a story, to paint drama across the blank canvas of the cosmos. It begins with pattern recognition, an instinct that once saved lives. When hunters saw broken grass, they imagined a predator. When early farmers noticed the phases of the moon, they tied it to the seasons. This ability to connect dots, to see the unseen, became the foundation of survival. But the same instinct turned skyward also transformed ordinary events into extraordinary dramas. Consider a comet, a frozen rock trailing vapor as it approaches the sun. To astronomers, it is chemistry and physics at work. To the human imagination, it is something else entirely. A fiery sword, a divine messenger, a punishment from the gods, a herald of endings. Our brains recoil from randomness, so we stitch stories across the stars, convincing ourselves there must be intent behind the spectacle. This is what psychologists call apophenia, the tendency to perceive connections where none exist. In the night sky it becomes constellations, the hunter Orion, the scales of Libra, the scorpions that stung a giant. These patterns are beautiful illusions, comforting stories etched onto chaos. And when a new light appears, the story deepens. A comet blazing through a familiar constellation becomes not just an intruder, but a narrative twist. The heavens themselves seem to whisper. Even today the reflex is alive. When 3i Atlas was first tracked, its sheer size and unusual chemistry sparked endless theories. Was it a weapon, a probe, a relic of alien engineering? Never mind that science leaned toward natural explanations, the imagination galloped ahead. Forums filled with sketches of spaceships, articles framed it as the end of days, and memes painted it as Earth's incoming landlord come to collect rent. Once again, the pattern-seeking mind had turned a rock into a drama, and perhaps that is the deeper truth. The deception of patterns is not really deception at all, but expression. It reveals our hunger for meaning, our refusal to let the universe remain indifferent. A comet streaks across the sky, and instead of accepting it as coincidence, we pull it into our story. We make it part of our fears, our hopes, our myths. The universe does not send us signs, but we insist on reading them anyway. As you lie beneath the same sky tonight, think of it this way: each streak of light, each wandering visitor is a mirror. It reflects not only the cosmos, but also the restless imagination of the species watching from below. What begins as random dust and ice becomes through us an epic, a prophecy, or a bedtime story whispered into the dark. The story of 3i Atlas begins as so many cosmic tales do, with a faint smear of light in the dark. It was late 2024 when the asteroid terrestrial impact last alert system, better known as Atlas, picked up something unusual. At first, it seemed like any other icy body drifting near the edge of our detection range. Just another speck in the vast sky, another dot among thousands catalogued each year. But soon whispers began to stir among astronomers. This object did not behave like the others. The calculations came quickly. Its speed was staggering, nearly 30,000 miles per hour, a velocity far too great to be bound by the gravity of the Sun. It was not circling in some long elliptical orbit like a typical comet destined to return after centuries. No, this was different. Its path cut clean through our solar system, a hyperbolic trajectory, an unmistakable signature of something not from here. For the third time in recorded history, humanity was witnessing an interstellar visitor. Imagine the moment of realization, a handful of astronomers hunched over glowing monitors, coffee cooling beside stacks of data as the numbers revealed a truth larger than themselves. This was not a neighbor. This was a wanderer from beyond a fragment of the Milky Way itself passing through our backyard. A relic older than the Earth, older even than the Sun, now briefly brushing past our tiny world before vanishing back into the dark. The awe was immediate. To study such an object is to hold a fossil of another star system in your hands, to glimpse a shard of creation that formed billions of years ago and has travelled untold distances in silence. Scientists compared notes, ran simulations, traced its origin across the galactic map. Its birthplace was not our calm spiral arms, but likely the thick disk of the Milky Way, a chaotic region forged in fire when the galaxy was young. And with awe came imagination. Headlines called it a cosmic messenger, an alien probe, even a zombie from the stars. Social media painted it as a harbinger of disaster. But for the astronomers who first glimpsed its strange arc across the heavens, the reaction was quieter, deeper, a mix of wonder and humility. Because here in the cold numbers of trajectory and velocity was proof of something extraordinary. The universe still sends us surprises. Pause, and think of that moment somewhere far above our atmosphere. A rock the size of a city moved silently past, indifferent to us, yet carrying stories written in its dust. We are small, fragile, temporary, and yet we can see it. We can calculate its speed, predict its path, and name it. To glimpse a wanderer is to glimpse ourselves, creatures of Earth, but with eyes that can follow a traveller from the stars. To hold the story of Three-Eye Atlas in your mind is to stretch your imagination across billions of years. Our Earth itself is 4.5 billion years old, a span of time that feels immeasurable, almost infinite. And yet this visitor, this wandering fragment of ice and stone, is older still. Over 7 billion years old, born before our Sun first ignited, before the planet spun into being, before the Earth itself was even a thought in the cosmic mind. Think of that. When Three-Eye Atlas formed, the galaxy was young, its spiral arms still stitching themselves from the debris of ancient stars. The thick disk of the Milky Way was turbulent, then a place of violence and birth. Supernovae tore apart the darkness, scattering the heavy elements needed for worlds and life. Clouds of gas collapsed under their own weight, forming stars by the millions. And amid this chaos, pieces of rock and ice began to coalesce, fragments like Three-Eye Atlas, shaped in the furnace of creation. While Earth was still dust, still swirling in the protoplanetary cloud that would one day cradle oceans and forests, Atlas was already on its journey. It orbited its parent star for perhaps billions of years until some distant gravitational encounter flung it free. Since then, it has wandered the galaxy, a silent drifter passing through regions of light and darkness, through arms of stars and gulfs of void unbound by any home. Astronomers marvel at such an object because it is in essence a time capsule. It carries with it the chemistry of its birthplace unaltered by the heat and complexity that shaped Earth. To study it is to peer backward not just into our own history, but into the prehistory of the cosmos itself. Its molecules may tell us what the universe was made of when our world was not even conceived. Its dust may contain the seeds of carbon, nitrogen, and cyanide, the building blocks of life scattered long before life had anywhere to grow. There is a strange humility in realizing that Atlas is older than every mountain, older than every ocean, older than life itself. Dinosaurs, pyramids, empires, they are all flickers, candle flames that rise and fall in an instant compared to this one frozen stone. It has endured the birth and death of stars. It has seen civilizations rise in silence and collapse without a sound, and now briefly it passes near us, brushing our awareness, reminding us how young, how fleeting we truly are. To call it a relic is not to diminish it, but to honor its endurance. It is a survivor of cosmic history, a piece of the universe's memory that no living creature can recall. For 7 billion years it travelled without eyes to see or minds to remember, and now for a flicker of time we see it. We give it a name, we tell its story. In that moment the ancient and the new meet a relic of deep time, reflected in the fragile consciousness of a species just learning to lift its gaze to the stars. If 3i Atlas is a relic, then its birthplace was no quiet cradle. Astronomers believe it likely came from the thick disk of our Milky Way, a region that tells a story of violence and birth of stars colliding and new worlds being forged in fire. To imagine the thick disk picture the galaxy, not as the calm spiral we see in paintings, but as a layered structure, a thin disk where most stars, like our Sun, now dwell, and a thicker, puffed-up halo of older stars and ancient debris. This thick disk was born in turbulence. Billions of years ago, the Milky Way was young and restless, colliding with the smaller galaxies, stirring gas into storms, setting off chain reactions of star formation. The stars in this region are older, more metal-poor, their chemistry forged before elements like iron and gold became plentiful. It was amid this primitive abundance, hydrogen, helium, and the raw materials of carbon that icy bodies like 3i Atlas first took shape. In those chaotic times, gravity was both creator and destroyer. Planets were flung from orbits. Stars were born in clusters only to drift apart. Comets and asteroids were hurled into interstellar exile, carrying with them the fingerprints of their violent origins. For billions of years, the thick disk has been a graveyard and a nursery all at once. It holds some of the galaxy's most ancient stars, stars that have burned for nearly as long as the universe itself. Their light is faint now, red and tired, but still reaching us across unimaginable distances. To know that 3i Atlas may have been formed in this realm is to glimpse not just its age, but its heritage. It is a child of chaos shaped by collisions we can scarcely imagine sent adrift before Earth even existed. What makes this extraordinary is not only the science, but the symbolism. The thick disk is a reminder that our galaxy is not a static painting, but a living, shifting organism. It grows, it collides, it evolves. And from that restlessness come wanderers like Atlas fragments cast out into the dark, destined to travel endlessly, until by pure chance they pass close enough for a young civilization like ours to notice. So when astronomers trace Atlas's trajectory and point back toward the thick disk, they are not just plotting a course, they are pointing toward the galaxy's turbulent childhood, toward an era when the Milky Way was still finding its shape. And in that ancient upheaval, a frozen stone began a journey so long, so improbable that tonight, billions of years later, you are hearing its story. For all its silence, 3i Atlas has stirred one of the loudest debates in modern astronomy. At first glance, it should be just another comet, an icy fragment wandering through the void lit by sunlight, glowing faintly as it releases gas. But when scientists ran the numbers, something unsettling emerged. Its trajectory did not quite make sense. Harvard astronomer Avi Loeb, known for daring to ask questions that many shy away from, calculated the odds. The chance of Atlas arriving on its current path naturally without any hidden push or unseen influence was astonishingly low, just 0.005%, less than 1 in 20,000. In other words, according to the math, Atlas is not behaving like the universe's usual dice roll. It is an outlier, a stranger among strangers. Now, statistics are not proof. Science thrives on probabilities, not certainties, but such improbability raises a haunting possibility. If its trajectory is not the product of chance, then what is guiding it? Could it be some hidden gravitational influence, a star we have not accounted for, or an ancient slingshot maneuver through unknown systems? Or this is the leap that makes headlines. Could it be intentional? Loeb himself is cautious but provocative. He suggests that when the odds of natural origin fall so low, we must at least entertain alternatives. Perhaps Atlas is not just a comet, but something more, a probe, a relic of technology, a drifting monument left behind by intelligence elsewhere in the galaxy. His words spark controversy, dividing the scientific community. Most astronomers insist the object is natural, pointing to physics, chemistry, and the need for evidence. Yet a small minority keep the door open, refusing to dismiss the improbable. What makes this fascinating is less the conclusion than the question itself. Humanity is not accustomed to considering the possibility of visitors. We imagine aliens in science fiction, yes, but rarely in scientific journals. And yet here is a voice from one of the world's leading institutions saying, the numbers don't fit. We must look closer. There is a quiet thrill in this moment. Perhaps it is nothing, a quirk of measurement, a comet with odd chemistry and an unusual path. Or perhaps hidden in the cold dust of Atlas lies a story far larger than we ever expected. The cosmos does not hand us certainty, it offers mysteries wrapped in improbability, and sometimes the smallest statistical anomaly can open the largest questions of all. When the James Webb Space Telescope turned its golden mirrors toward 3i Atlas, it was like holding a magnifying glass to a relic older than Earth. Light stretched across billions of miles carried secrets of its composition, tiny whispers etched into spectra waiting to be translated. And what Webb found was both familiar and unsettling. The readings showed carbon dioxide pouring from its surface, a common signature for comets. Alongside it came traces of cyanide, that bitter poison so often woven into stories of spies and assassins here on Earth, but in space a surprisingly common molecule. Cyanide may sound sinister, but in the cosmic scale it is a building block, an ingredient that under the right conditions can stitch itself into the scaffolding of life. There was also nickel, a heavy metal, one of the fingerprints of stars that lived and died long before our sun. Nickel is expected in the cores of planets and asteroids forged in supernovae, scattered across galaxies like glitter, shaken from a hand. To find it in Atlas is not surprising, but it is significant. It means this wanderer carries the dust of ancient explosions, echoes of suns that burned out before our world began. But then came the anomaly: no iron. For a comet of this size, iron should be there, locked in its heart, bound in its dust. Yet Webb's instruments, precise and relentless, found none, a silence where there should have been a presence. In science, such absences are as loud as discoveries. Why would a comet rich in nickel, cyanide and carbon dioxide be stripped of iron? Was it forged in an unusual environment? Or this is where imaginations lean forward, was it altered, sculpted, engineered? Some astronomers argue for natural explanations. Perhaps Atlas formed in a star system where conditions were skewed, where iron was scarce or locked away in other bodies. Others whisper that the absence is more telling a fingerprint of the unnatural. If someone somewhere had once harvested resources from Atlas, or designed it for a purpose, the lack of iron might be the residue of that touch. The truth remains out of reach, yet the chemistry of Atlas feels like a message written in starlight, familiar elements mixed in strange proportions, a recipe that does not quite match the cookbook of known comets. In its breath of gases, we hear both science and story, the steady voice of data, and the quieter echo of possibility. As you picture Atlas drifting now, imagine it not just as ice and dust, but as a kind of library. Each molecule is a page, each absence is a blank space daring us to fill it. And somewhere between carbon cyanide and nickel, we find the same haunting silence that has followed humanity for millennia. What else, if anything, is out there? Every comet carries a signature, a tale of gas and dust streaming away from the sun, sculpted by radiation and the solar wind. It is one of the most beautiful sights in the heavens, a glowing veil unfurling across the dark. But when astronomers looked closely at 3i Atlas, they saw something that broke the rules. Alongside its normal tail, it bore an anti-tail. An anti-tail is a strange phenomenon where instead of streaming away from the sun, a second tail seems to point toward it. At first glance, it feels impossible, like smoke drifting back into the fire. For most comets, this is rare, but explainable, the result of geometry and the peculiar dance of dust particles caught in gravity's web. But with Atlas, the anti-tail glowed with unusual clarity, as though daring us to question it. To some, this was a red flag. A tail that refuses to behave feels like defiance, like a sign of something engineered rather than natural. Whispers spread in scientific forums and late-night discussions. Was this evidence of propulsion? A signature of controlled movement. Could Atlas be more than a comet? Could it be a craft, its anti-tail the exhaust of a hidden engine? Most astronomers urge caution. There are, after all, natural explanations. Dust can collect in thick, narrow sheets, and when Earth crosses the plane of that dust, the comet appears to sprout a tail pointing the wrong way. It is not the comet reversing the laws of physics, but our perspective catching the illusion. Still, in Atlas's case, the anti-tail was unusually pronounced, its structure harder to dismiss. The debate reveals something telling how quickly the human imagination fills the void. One group sees the anti-tail and reaches for physics textbooks sketching diagrams of dust orbits and solar radiation. Another sees it and imagines alien engines humming in the dark, guiding atlas across interstellar gulfs. Neither explanation can be proven in full, and so the anti-tale hangs there, both phenomenon and metaphor. A line of light across the cosmos dividing skepticism from wonder. Perhaps the truth lies in between. The anti-tale may be nothing more than dust, yes, but it is also a reminder of how the universe teases us with shapes and patterns that look designed even when they are not. And in that tension, in that razor's edge between natural and artificial, our species lingers restless, unwilling to let go of the dream that one day one comet, one visitor might truly not be alone. When Oumuamua first slipped past us in 2017, it was no bigger than a mountain, perhaps 400 meters long, a sliver of rock compared to the planets and moons that surround us. Small, swift, enigmatic. By contrast, 3i Atlas is a giant. Nearly 46 kilometers across, it is more than 100 times larger than Oumuamua and 1,000,000 times more massive. In the catalogue of interstellar visitors, it is not just an entry, it is an anomaly. Statistically, this should not have happened. Most objects wandering between the stars are small fragments chipped off by ancient collisions, easily nudged into interstellar exile. To encounter even one such traveller in a human lifetime was improbable. To meet two in less than a decade, first Oumuamua, then Borisov in 2019, already strained the odds. And now Atlas, massive, intact, roaring through space like a cathedral of ice. It is as though the universe, silent for eons, suddenly began sending us guests one after another. The sheer size of Atlas raises questions. Why would an object this large survive ejection from its parent system? How did it travel billions of years without being torn apart by gravitational tides, shattered by collisions, or eroded to dust? Its endurance defies not only probability, but expectation, standing as a silent rebuke to our models of interstellar debris. Some astronomers suggest it is simply luck that we happen to live in an era when detection tools have finally sharpened enough to reveal what has always been there. Perhaps these wanderers have always passed by unnoticed in the deep sky, and now we are at last catching them in our nets. Others argue that Atlas may itself be rare, a statistical outlier that challenges our assumptions. Like a lone giant tree in a forest of saplings, it draws attention because it should not be here, and yet it is. The human imagination, of course, seizes on the scale. A 46-kilometer object is no mere comet. It is a moving world, a frozen mountain range adrift among the stars. If it were to strike Earth, it would not just scar the surface, it would end the story of humanity in an instant, leaving only whispers in the rock. Thankfully, its path will never come close enough to threaten us. But its size makes it impossible to ignore a reminder that the cosmos does not play by our sense of scale or fairness. In statistics, outliers force us to rethink the pattern. In life, they become legends, and 3i Atlas. This improbable wanderer has already joined both categories. Whether natural relic or something more, it demands our attention, not because it threatens us, but because it dares us to imagine what else drifts unseen in the endless dark. For all the headlines, for all the whispered theories and midnight anxieties, 3i Atlas carries no danger for us. Its path is already written, its course mapped with precision. On December 19th, 2025, it will make its closest approach to Earth, passing at a distance of about 168 million miles. To put that into perspective, that is nearly twice the distance between Earth and the Sun at its farthest point. In cosmic terms, it is a polite way from across the street, not a collision course. The reassurance is worth repeating. Atlas is not coming for us. It will not blaze through our skies with catastrophic impact, nor darken our atmosphere with dust. For all its size, for all its statistical oddity, it is only a passerby, a silent guest glimpsed from afar. The Earth will continue its orbit, oceans will rise and fall with the tides, and humanity will wake on December 20th no different than the day before. And yet there is something profound in knowing when it will pass. Imagine the moment astronomers across the world, from mountaintop observatories to backyards with modest telescopes, tilting their eyes towards the faint smudge of a visitor that has travelled billions of years to brush our awareness. Families may stand outside in the chill of winter nights gazing upward, at a dot too faint for most eyes, but glowing all the same in the mind. A relic of another star system here, for one brief encounter, then gone forever. There is comfort in this perspective. In an age where news thrives on fear, here is a reminder that not every strange object in the sky is a threat. Sometimes it is only a story, an opportunity to look beyond our small world and remember the scale of the universe. The sky is vast, and most of what passes through it does so without malice or consequence. Atlas is not an enemy, it is a messenger of perspective. When the date arrives, it will pass quietly without spectacle to the naked eye. But if you close your eyes that night, you might imagine it a giant of ice, 46 kilometers wide, drifting past at unimaginable speed, older than the Earth itself, brushing by like a stranger in a crowded station. No words exchanged, no harm done. Only the reminder that in the endless corridors of space we are not alone in our wandering. If 3i Atlas is not a threat, then why does it matter? The answer lies not in its icy bulk, but in what it represents: distraction. Humanity has always been vulnerable to spectacle. Our eyes are drawn to the extraordinary, the mysterious, the newsworthy. A comet older than Earth, the size of a small moon drifting from another star. It's irresistible. It fills headlines, dominates late-night debates, and fuels rumours of alien probes. But while our attention burns brightly on the exotic, the real dangers are often the quiet ones. Mundane asteroids far smaller than Atlas, yet infinitely more threatening, pass through our neighbourhood every year. They lack the glamour of interstellar origin, so they rarely make front-page news. Yet these are the rocks that could one day end cities or civilizations. They are not travelling at polite distances of hundreds of millions of miles. They are slipping by Earth in near misses, measured not in millions but in thousands of miles. This is the peril of distraction. When the world is fixated on a cosmic giant that poses no harm, we risk neglecting the countless smaller invisible threats creeping closer. Consider how much energy and funding pours into discussing alien probes or end-of-days speculation, while detection programs often run on modest budgets with limited telescopes scanning only a fraction of the sky. The irony is sharp. Our species debates the possibility of intelligent visitors while struggling to track the very real, very dumb rocks that could erase us overnight. The cosmos does not need imagination to threaten us. A 50-meter asteroid smaller than a football field could devastate a city. A kilometer-wide impactor could throw the world into famine. These objects are not myths or maybes. They are known quantities, catalogued risks, each one a silent bullet in a revolver spun by chance. And yet their stories seldom capture us the way a visitor like Atlas does. Perhaps it is human nature. We crave the extraordinary, the strange, the once-in-a-billion anomaly. But survival depends on something less: romantic vigilance. To protect our fragile world, we must look not only at the glittering giant passing far away, but at the countless shadows lurking close by. The true danger is not Atlas, it is forgetting where to keep our eyes. If you want to understand why distraction is dangerous, consider the story of asteroid 24YR4. It wasn't interstellar. It wasn't enormous. It didn't glow with mystery or stir whispers of alien origin. To most of the world, it was invisible, unnoticed, unnamed. And yet for a brief, chilling moment, it carried a chance, small but real, of rewriting history. When YR4 was first spotted, astronomers quickly ran the numbers on its trajectory. The result, a 2.1% chance of impact in the year 2032. 2 in 100. To the average person, that might sound like a coin toss weighted heavily towards safety. But in planetary defense, those odds are staggering. Imagine if someone told you that every time you boarded an airplane it had a 2% chance of falling from the sky. Would you still climb aboard? The danger lay not only in probability but in power. If YR4 had struck Earth, the impact energy would have been equivalent to 400 Hiroshima bombs detonating at once. Not enough to wipe out the planet, no, but easily enough to erase a city, plunge a region into disaster, and shake global society. A random draw of the cosmic lottery could have placed that explosion over a desert, an ocean, or a metropolis of millions. The asteroid didn't care. For a few tense days, scientists around the world held their breath. Telescopes turned toward the faint speck of light, recalculating, refining, narrowing the margins of the error. Each new observation was a heartbeat. Would the line of data bend away from Earth, or closer humanity's fate, balanced on numbers scribbled in chalk across observatory blackboards on streaks of pixels captured in the cold silence of the night sky? And then slowly relief. Additional tracking revealed that YR4 would not strike after all. The 2.1% dwindled to zero. The danger had passed almost as quickly as it appeared. The world went on as if nothing had happened. No headlines. No collective sigh. Outside the small community of astronomers and planetary defense experts, hardly anyone even knew we'd been on edge. This is the unsettling lesson. While attention flares around a harmless giant like Atlas, the real bullets, the small, fast near-Earth rocks slip by, almost unnoticed. Some arrive with fanfare, others in silence. And sometimes for a brief moment they carry odds that should make us shiver. Odds like YR4's 2% backed by the firepower of 400 atomic suns. The universe does not warn us with trumpets or bright neon signs. It whispers improbabilities in faint lines of light on a telescope image. And if we are not watching closely, we may never hear the warning until it is too late. When asteroid 2024 YR4 first appeared on our radar, the numbers were unnerving, a small but real chance of impact enough to send a ripple of unease through the scientific community. But the story of YR4 is not only about risk, it is also about response. In those first tense days, NASA's planetary defense teams and observatories around the world moved with urgency, proving just how critical vigilance can be. The process is both elegant and relentless. When a new object is discovered, astronomers scramble to track it again and again and again, every fresh observation shrinking the margin of uncertainty. Think of it like sketching the path of a bird across the sky. With only a glimpse, you can guess its direction, but the guess is wide. Watch it flap a few more times and the trajectory sharpens. Watch long enough and you know exactly where it will land. So it was with YR4. Telescopes from Hawaii to Chile swung toward the tiny moving speck, measuring its brightness, its motion against the stars, its faint whisper of reflected sunlight. Supercomputers churned through the data, updating simulations by the hour. Each new line of math pulled the asteroid's possible futures into focus, and slowly the nightmare scenario faded. Within days, the risk of impact dropped from 2.1% to fractions of a percent, then to nothing at all. YR4's orbit resolved into clarity, revealing a safe path that would never intersect Earth. What had seemed at first glance like a loaded gun aimed at the planet turned out to be a harmless flyby. Most of the world never knew, the news barely mentioned it, overshadowed by louder stories. But for the scientists who had tracked it, the relief was profound, not just because the Earth was safe, but because the system had worked. The early alarm, the quick mobilization, the international collaboration. This is how planetary defense is supposed to function. Not in panic, not in secrecy, but in vigilance, in patient measurement, in the quiet confidence of numbers. The lesson is simple: danger often arrives not in certainty, but in possibility. YR4 could have been catastrophic, but it wasn't. And the only reason we know that is because we looked, we measured, we stayed awake beneath the sky. Vigilance turned fear into knowledge and knowledge into safety. In a universe full of wandering stones, that vigilance may be the only thing standing between us and silence. When you picture the night sky, perhaps you imagine stillness, stars like pinpricks frozen on black velvet planets drifting slowly in their orbits, the moon rising with steady grace. But beneath that calm, the reality is far more unsettling. Space is not empty, it is crowded. The Earth does not drift through silence, but through a shooting gallery of ancient debris, a sky full of bullets. As of September 2025, NASA is actively tracking two 493 potentially hazardous asteroids. Each one is defined as hazardous because of its size large enough to cause regional or global damage, and because its orbit passes close enough to Earth to be dangerous. These objects range from city killers a few hundred meters across to giants several kilometers wide, each with the destructive potential to end life as we know it. Imagine that number for a moment. 2,493. Nearly 2 to 500 cosmic projectiles, each one with the capacity to scar continents or plunge the world into chaos. And those are only the ones we know about. Thousands more too small or too dark to detect yet lurk in the shadows of space. Some may be passing right now, unrecorded, untracked, slipping through the blind spots of our watchful eyes. It's easy to dismiss this as abstract as numbers on a page. But remember, every one of those 2,493 rocks follows a path written in gravity. A path that could, in the long arcs of centuries, intersect ours. The Earth is not immune. It has been struck before. The craters on our moon, the scars across ancient landscapes, even the story of the dinosaurs, these are reminders carved into stone that impacts are not hypothetical. They are history. Astronomers often describe these asteroids as near-Earth objects, but near is a deceptive word. It does not mean imminent danger. It means that in the vast ocean of space, their orbits cross our lane like ships that could one day collide. Most will pass harmlessly, a few will skim close enough to raise the hairs on our necks, and one someday might not miss. To live on Earth is to live in this crowded neighborhood. Each dawn as the sky brightens and we go about our ordinary lives, invisible stones continue their orbits indifferent to us. We may never meet them. Or we may. That uncertainty is part of the human condition. It is why we look up, why we track, why we calculate. Because survival depends not on ignoring the bullets, but on knowing where they are aimed. Among the thousands of rocks that drift through our neighbourhood, some skim uncomfortably close. One of the most striking examples came with asteroid 2013 TX68. When it was first discovered, its orbit was difficult to pin down. The data suggested that on a future pass, it could sweep within 250,000 miles of Earth, closer than the Moon itself. To picture that, imagine looking up at the night sky, seeing the Moon, and knowing that a tumbling boulder of stone and metal could thread the gap between us and it, a cosmic near miss. On a galactic scale, it is nothing, barely a brush. But for us here on Earth, it is a razor-thin margin. 2013. TX68 was not enormous, only about 100 feet across, smaller than many of the skyscrapers that light our cities. But its potential impact to energy was staggering. If it had struck the Earth, it could have unleashed the force of dozens of nuclear weapons. Not enough to end civilization, but enough to devastate a region, to flatten a city, to scar the Earth for centuries. And what makes this story more unsettling is how uncertain it was. Early on, astronomers could not say for sure how close it would come. The predictions carried a blur, a margin of error, that made the difference between safety and impact. Would it pass harmlessly by, or would the line of probability bend toward catastrophe? For weeks the answer was not clear. In the end, TX68 missed us comfortably, slipping by with no harm done. But its passage left behind a reminder carved in anxiety: the margins are thin. Space is vast, but gravity is precise. A shift of a few thousand miles, a wobble in orbit, and what passes unnoticed could become history's headline. These close calls are sobering. They show that survival often depends not on certainty, but on luck. And luck, as history tells us, is not a strategy. Each asteroid like TX68 is a warning, a whisper that says the next one might not miss. For all our telescopes, satellites, and clever mathematics, our vigilance is far from perfect. The truth is unsettling. We cannot see the whole sky at once. And the most dangerous blind spot of all lies where our greatest light shines, the sun. Astronomers call it the sunward blind spot. Any asteroid approaching Earth from the direction of the sun is almost invisible to ground-based telescopes. The glare overwhelms sensitive instruments, washing out the faint light of a rock hurtling through space. It is like trying to spot a firefly against the beam of a floodlight. You know it might be there, but the brilliance blinds you. This gap is not theoretical. It has consequences. Many near-Earth objects slip past undetected because of it. Some are discovered only after they have already passed, missed bullets we never even saw fired. The unsettling part is that some may be discovered too late, detected only days or even hours before a potential impact. In such cases, there is no time to plan, no time to deflect, no time to evacuate. The universe would give us no warning. The sun's glare is not the only challenge. Some asteroids are dark, almost invisible, coated in carbon-rich material that absorbs light. They do not shine, they hide. Others tumble irregularly, flashing unpredictably, making their motion harder to track. Still others are rubble piles, loose collections of rock held together by gravity, which scatter light in ways that confuse our instruments. Each is a puzzle piece that resists easy placement on the cosmic map. And so, despite our technology, Earth still lives with blind spots. We track what we can, but thousands of objects remain uncatalogued, waiting in the silence. The irony is sharp. We have mapped to distant galaxies, peered into the edge of the observable universe, and photographed black holes. But the rocks that pose the most immediate danger to our survival sometimes slip past hidden in the glare of our own star. This is the sobering balance of progress. We know more than ever before, and yet the very nature of our cosmic vantage point means there will always be shadows we cannot pierce. Survival then is not certainty, it is vigilance, patience, and the acceptance that the sky still holds secrets we have yet to uncover. If you need proof that the blind spots in our sky matter, look no further than the morning of February 15, 2013 in Chelyabinsk, Russia. There was no warning, no global alert, no time to prepare. Out of a clear winter sky, a fireball tore across the horizon, brighter than the sun. For a moment it looked like the dawn of another world or the end of this one. The object was small by cosmic standards, only about 20 meters wide, roughly the size of a house. Too small to be catalogued, too faint to be noticed before it arrived. But size is deceptive. Travelling at nearly 40,000 miles per hour, it carried the energy of 30 Hiroshima bombs compressed into a single instant. When it exploded in the atmosphere, the blast was blinding, a shockwave that raced across the landscape faster than sound. Windows shattered across 6 cities. Walls cracked, roofs caved in. Nearly 1,500 people were injured not by the fireball itself, but by glass and debris hurled inward as shockwaves struck homes, schools and offices. Security cameras captured the event in vivid detail, a streak of white across the sky, a flash, and then, seconds later, the concussive boom that rattled the earth. For those who saw it, the fear was primal. Children screamed. Adults thought war had begun. The sky itself had turned hostile. And here is the sobering truth: no one saw it coming. The Chelyabinsk meteor approached from the direction of the sun, hidden in that deadly blind spot. It was discovered only in hindsight when scientists traced its orbit backward. If it had struck at a slightly different angle, or over a densely populated city, the casualties could have been far worse. Chelyabinsk was a warning wrapped in fire, a reminder that not all cosmic threats wear the face of extinction. Some are smaller, more subtle, yet devastating all the same. It showed us that even in the modern world, with satellites in orbit, telescopes on mountaintops and global networks of communication, we are still vulnerable to the sudden arrival of stone from the sky. In the aftermath, governments pledged to expand asteroid detection programs. Funding increased, missions were proposed, and awareness briefly sharpened. But as years passed, the urgency faded. Chelyabinsk slipped into the memory, a story retold by scientists and journalists, but largely forgotten by the wider world. And yet above us, the sky remains full of stones, each one indifferent to whether or not we are paying attention. After Chelyabinsk, one question lingered like smoke in the air: how many more are out there hidden in the sunlight waiting? The truth was unsettling: too many. But the answer was not despair. The answer was to build new eyes that could pierce the glare where human sight falters. Out of that determination came one of the most ambitious missions of our time, NASA's NEO-Surveyor. Planned for launch in 2027, NEO-Surveyor is not a telescope in the traditional sense. It does not rely on visible light, the same narrow spectrum our eyes see. Instead, it peers into the infrared, detecting the heat radiating from asteroids and comets. This shift is revolutionary. Even if a rock reflects almost no sunlight, dark as coal, invisible against the starfield, it still glows faintly with its own warmth. A NEO-Surveyor is designed to find that glow. The telescope will orbit the sun at a special vantage point called L1, a gravitational balance point between Earth and Sun. From there, it will have an unobstructed view free from the haze of Earth's atmosphere, scanning wide swaths of the sky with sensitivity far beyond current ground-based systems. Its mission is simple but profound: to detect, track and catalogue the near-Earth objects that could one day threaten us. Think of it as a cosmic early warning system, a smoke detector for the entire planet. Where our current surveys might give us months or years of notice, NEO-Surveyor could give us decades. And in planetary defense, decades make the difference between helplessness and action. With enough warning, asteroids can be deflected, nudged, or redirected. Without warning, we can only brace for impact. But NEO-Surveyor is more than just a guardian. It is also a teacher. By cataloguing thousands of objects in unprecedented detail, it will reveal the architecture of our solar system's debris field, showing us how rocks and ice flow between planets, how fragments of ancient collisions still wander in orbits shaped billions of years ago. In its data will be history not just of threats but of origins. There is hope in this. For the first time in history, our species is not blind before the cosmos. We are building the means to see what once struck without warning. NEO-Surveyor is a reminder that technology born of curiosity and necessity can tip the scales in our favour. It does not guarantee safety, but it gives us something we have never truly had before: time. And in a universe full of silent wanderers, time is the difference between fragility and survival. When we imagine asteroids, it's tempting to picture them as solid, iron-hard boulders, simple stones flung through space. But the truth is far stranger and far more dangerous. Asteroids come in many forms, and each carries its own peculiar threat. Some are what scientists call rubble piles, vast heaps of rock and dust loosely held together by gravity like a floating junkyard. To the eye they look solid, but in reality they are fragile, porous, ready to crumble at the slightest disturbance. Try to strike or nudge such an object, and it may not deflect, it may break apart, splitting into countless smaller fragments, each one still carrying deadly momentum toward Earth. A single asteroid could suddenly become a shotgun blast of destruction. Others are dark asteroids coated in carbon-rich material that makes them almost invisible against the blackness of space. They reflect little sunlight, hiding even from sensitive telescopes. Some are so stealthy that they remain unseen until they brush terrifyingly close. Chelyabinsk's meteor was small, but imagine a larger dark body slipping past unnoticed until it is too late to react. These are the cosmic assassins cloaked in shadow, patient and silent. Then there are the tumblers asteroids that spin chaotically as they travel rolling, end over end like dice tossed through the void. Their irregular shapes reflect light unpredictably, confusing our instruments. Calculating their paths becomes more difficult, their orbits less certain. Some tumble so wildly that their gravity is uneven, reshaping the dust and boulders clinging to their surfaces in ways we are only beginning to understand. And some asteroids, instead of being loose rubble, are dense metallic giants rich in nickel and iron, forged in the hearts of dead stars. These are harder to deflect, heavier, and far more devastating if they strike. Their density means that even smaller ones can penetrate Earth's atmosphere without breaking apart, delivering their full energy to the surface. Each variety poses a unique challenge. A rubble pile may resist force but crumble unpredictably. A dark asteroid may hide until it is nearly upon us. A tumbler complicates calculations, denying us the precision needed for long-term planning. And a metallic giant carries brute force enough to scar continents. There is no single defense strategy, no universal plan. To face them, we must understand them, every quirk, every weakness, every danger. This is why missions like NASA's DART and ESA's Hera are so crucial. They are not only tests of deflection, but lessons in asteroid character. For if we fail to recognize the nature of the stone before us, then even the best technology may stumble. And in planetary defense, misunderstanding is as dangerous as inaction. The universe has filled our neighborhood with a gallery of strange wanderers. Some are fragile, some are hidden, some are unpredictable. All of them remind us that survival depends on more than vigilance. It depends on knowledge, and knowledge in this case may be the only shield we truly have. For as long as humanity has looked to the sky in fear of falling stars, we have wondered, could we ever stop one? Could we deflect a cosmic bullet before it struck? For centuries, the idea belonged only to myth and imagination. Gods hurled comets, kings trembled beneath fiery omens, and poets wrote of destruction from above. But in September 2022, for the first time in history, that question was answered, not with prophecy, but with proof. NASA's DART mission. The double asteroid hole redirection test was deceptively simple in concept. Take a spacecraft the size of a vending machine, launch it across millions of miles, and crash it head-on into an asteroid's moonlet. No explosives, no nukes, just a deliberate kinetic shove. The target was Dimorphos, a 160-meter-wide rock orbiting the larger asteroid Didymos. If the impact changed Dimorphos's orbit even slightly, it would prove that humanity had the power to push the cosmos however gently. The world watched the final minutes of DART's approach in awe. The spacecraft's camera streamed images as it hurtled toward its target at 14,000 miles per hour. First a tiny speck, then a lumpy potato shape filling the frame, and then impact. The screen went black. Humanity had punched an asteroid. The results were more dramatic than expected. Dimorphos's orbit around Didymos shortened by 32 minutes, a much greater change than scientists had dared to hope. Dust and debris billowed out into space, forming a glowing tail, visible even from ground-based telescopes. The proof was undeniable. With enough warning, a spacecraft could shift the course of a rock that might otherwise threaten Earth. For the first time, planetary defense was not theory, it was reality. This success carried more than scientific weight. It was symbolic. For millennia we lived under the sky as passive spectators, vulnerable to whatever it sent us. DART was a declaration that we are no longer helpless. We cannot control the stars, but we can push back against their stones. Humanity had reached into the void and moved a world, however small. Of course, challenges remain. Not every asteroid will be like Dimorphos. Rubble piles may absorb the blow, metallic bodies may resist it tumbling, objects may confound our aim. But DART was a beginning, a proof of concept, a seed of confidence. It showed that with vigilance, cooperation, and courage we can defend our fragile blue planet. It is a quiet triumph, easily forgotten in the rush of everyday news. But someday perhaps it will not be forgotten. Someday when a larger asteroid appears on a collision course and humanity launches fleets of deflectors, we will look back at Dimorphos and remember this was the moment we first learned to fight back. When NASA's DART spacecraft slammed into Dimorphos, it was like throwing a stone into a dark pond. You see the splash, but not the ripples that follow. We knew the orbit had changed. We saw the cloud of dust expanding outward, trailing into a comet-like plume. But what happened to the asteroid itself was it cracked, reshaped. We needed to know, because the next time we try to deflect a rock, the stakes may be far higher. That is where ESA's Hera mission enters the story. Launched in 2024, Hera is humanity's detective. While DART was the punch, Hera is the magnifying glass. Its mission to travel to the Didymos-Dimorphos system and study in painstaking detail the aftermath of our first planetary defense experiment. Hera will map Dimorphos' new orbit with precision, measuring every wobble and shift. It will take close-up images of the crater blasted into its surface, revealing whether the impact gouged a deep scar or merely scattered rubble. It will probe the asteroid's internal structure, asking is it a solid body or a fragile rubble pile barely held together. These details matter enormously. A dense rock responds differently to a shove than a loose heap of stones. What works for one asteroid may fail for another. Accompanying Hera are small CubeSats, tiny spacecraft designed to fly close, take readings, and even drop radar into cracks to scan Dimorphos' insides. Together they will turn the Didymos system into a laboratory where the language of rocks and dust is read as carefully as scripture. This is not just science for curiosity's sake, it is rehearsal. Someday, if a dangerous asteroid truly heads for Earth, our deflection strategy must be informed by knowledge, not guesswork. Hera's data will tell us how much force is needed, how momentum transfers through porous rock, how craters form in microgravity. It will transform DART's bold demonstration into a playbook for planetary defense. There is also a deeper symbolism here. The DART-Hera partnership is not one nation's triumph, but a global one. NASA and ESA working side-by-side, scientists from dozens of countries collaborating, all united by one truth: the sky does not recognize borders. An asteroid falling toward modern Earth threatens Moscow and Mumbai, New York and Nairobi alike. Hera is proof that the defense of our planet must be a shared responsibility. When Hera arrives and sends back its findings, it will do more than solve a scientific puzzle. It will mark another step in humanity's long journey from helplessness to agency, from fearing the sky to shaping our place beneath it. The success of DART and the promise of Hera inspire confidence, but they also come with a sobering reminder: not all asteroids are created equal. Dimorphos, the target of our first planetary defense test, was only 160 meters wide, large enough to flatten a city, yes, but tiny compared to the giants that wander through our solar system. Against those larger bodies, the scale of the challenge changes dramatically. Consider this. The asteroid that ended the reign of the dinosaurs 66 million years ago was about 10 kilometers wide. When it struck the Yucatan Peninsula, it released the energy of billions of nuclear bombs, igniting forests across continents, sending tsunamis tearing across oceans and filling the sky with dust that blotted out the sun for years. Life itself was nearly erased, and 75% of Earth's species vanished. Now imagine trying to stop something of that scale. A nudge from a vending machine-sized spacecraft like DART would be laughably insufficient. Even hundreds of such impacts would barely change its trajectory. The energy required to meaningfully deflect a 10-kilometer asteroid is almost beyond comprehension, comparable to the combined nuclear arsenal of the entire Earth detonated in space, directed with precision and delivered years in advance. And that is the crucial point: time is everything. The earlier we detect a threat, the smaller the push required. Alter an asteroid's course decades before impact, and even a gentle nudge can make it miss Earth by thousands of miles. Wait until the final years or months, and even our most powerful weapons may fail. Against a giant, desperation measures might look like nuclear devices detonated nearby to vaporize part of its surface, using the recoil of expelled gas to shift its path. Dangerous, uncertain, risky, but perhaps our only hope if time runs out. The physics is unforgiving. Mass scales faster than our ability to move it. A 46-kilometer object like 3I Atlas, though harmless on its current path, is so enormous that no realistic deflection plan exists. Against something of that size, humanity has no weapon, no shield. We could only watch. Survival would depend not on technology, but on chance, the hope that its orbit never crosses ours. This is why vigilance, early detection and preparation matter so deeply. Against the smaller stones we can act. Against the giants, we can only hope to see them coming in time to prepare for survival, if not deflection. The scale of the cosmos humbles us, reminding us that our victories like DART's triumph are first steps, not final solutions. In the end, planetary defense is a race not against asteroids, but against time. The rocks are out there, indifferent and eternal. Whether we live or fall depends on whether we notice them soon enough to make even the smallest push. If there is one lesson that echoes through every discussion of planetary defense, it is this: time is the deciding factor. Deflection is possible. DART proved that. Planning is possible. Missions like Hera and Neo-Surveyor remind us of that. But none of it matters without years, even decades of warning. Against the cosmos, late action is no action at all. Picture an asteroid the size of a skyscraper on a collision course with Earth. If we spot it 20 years out, the math is gentle. A nudge here, a small deflection there, and by the time it nears our orbit, it will miss us by thousands of miles. The tiniest push applied early becomes a life-saving gulf of distance. In space, centimeters per second become millions of kilometers over decades. But now imagine we discover the same asteroid only 6 months before impact. Suddenly every option narrows. The gentle nudge is useless. There is no time for small changes to accumulate. We are left with desperation nuclear detonations, high-risk attempts to shatter or vaporize it, emergency evacuations that could never cover enough ground. At best, we might soften the blow. At worst, we would simply watch the sky brighten with our ending. This is why astronomers speak so urgently of early detection. The danger is not only in the size of the rock, but in when we first see it. The Chelyabinsk meteor offered zero warning. Other objects have slipped past with days' notice. In such cases, even the best technology becomes powerless. A perfect deflection plan cannot succeed if it begins too late. The problem of time is also a problem of perspective. Humanity tends to focus on short horizons, election cycles, quarterly profits, immediate crises. But planetary defense demands patience and foresight. The asteroid that threatens us may not arrive for decades or centuries. To defend against it, we must act long before the danger feels real. That is not how our species is wired. But it may be the only way we survive. So as telescopes scan the heavens, they are not just mapping rocks. They are buying us time. Each discovery, each catalogued orbit is a gift of years in which strategies can be built, missions launched, nudges delivered. Without those years, even the strongest rockets and boldest ideas are useless. In the quiet arithmetic of survival, time is our most precious resource. And unlike money or power, it cannot be manufactured. It can only be earned by vigilance, by patience, by refusing to let our eyes close against the dark. Long before telescopes, before orbital mechanics, before science could strip the mystery from the night sky, comets were creatures of fear. To ancient eyes, the heavens were supposed to be steady and eternal. The constellations marched reliably with the seasons, the planets glided in graceful arcs. And then suddenly a stranger appeared, a blazing star with a trailing mane moving where no star should be. It was disruption written in light. Few celestial events inspired as much dread as Halley's comet. Returning every 6 years, it became the most famous harbinger of doom in human history. Chroniclers in 1066 wrote that its appearance was a fiery sword hanging over England, a divine omen of the Norman conquest. The Bayeux tapestry itself depicts the comet blazing above while King Harold's men cower in fear. To them, the fall of a kingdom was written in the sky. The Chinese, with centuries of meticulous records, called comets broom stars sweeping away dynasties. Their archives describe dozens of appearances, each linked to floods, earthquakes, or political upheaval. In one account, Emperor Qin Shi Huang, the man who built the Great Wall, was said to tremble at the sight of a comet blazing overhead, fearing it was a sign of heaven's disfavour. In Europe, comets were woven into the language of death and destiny. Medieval astrologers claimed they foretold plagues, famines, and the deaths of kings. When a comet appeared in 1456, Pope Calixtus III was so alarmed that he ordered special prayers to protect Christendom, ironically, at the same time as the Ottoman Empire was advancing on Europe. To the fearful, the two events seemed inseparable, the heavens and history conspiring together. Even in the Renaissance, when science began to challenge superstition, comets remained ominous. In 1664, a great comet appeared over Europe. Within a year, the plague swept through London, killing thousands. The connection was coincidence, but for those who survived, the link was seared into memory, a light in the sky, followed by death in the streets. Comets became not just astronomical events, but symbols, cosmic punctuation marks that announced endings. The fall of leaders, the crumbling of empires, the reshaping of history itself was written into their fiery trails. And though we now know comets as frozen wanderers, the ancient fear has never fully left us. Even today, when a comet blazes, unusually bright articles appear, whispers spread, and somewhere in the human mind the old instinct stirs. What does it mean? Perhaps that is why objects like 3i Atlas so easily ignite speculation. They are part of a long tradition, a deep reflex in our storytelling. When something new streaks across the heavens, we do not only see ice and dust, we see history, prophecy, and the shadow of endings. When words fail to capture the terror of a blazing sky, artists turn to image and verse. For centuries, comets became muses of dread, painted as swords of fire, written as divine warnings, filmed as the end of days. Through art, fear was immortalized. In medieval manuscripts, comets appear as streaks of blood across the heavens, sketched in margins alongside kings and angels. To the illuminated mind, they were not ice and dust, but flaming spears hurled from heaven's hand. In the Bayeux tapestry, Halley's comet hangs ominously above the soldiers of 1066, woven in golden thread as a symbol of destiny's judgment. The weavers could not have known they were preserving not just history, but fear itself stitched into fabric for all time. Painters of the Renaissance carried the torch. In 1577, a great comet blazed over Europe and artists rushed to capture it. Woodcuts showed it as a fiery dragon coiled in the sky, breathing ruin upon villages. Some portrayed it as a sword gleaming with heavenly fire, hanging over cities like the blade of Damocles. The comet was no longer just an object, it was narrative allegory, a painting of doom visible to all. Poets too found language in the fire. Shakespeare wove comets into his plays, linking them with the fall of kings and the unravelling of fate. John Milton in Paradise Lost likened Satan himself to a comet, blazing ominously across creation, a harbinger of chaos and ruin. The streaking light in the heavens became the perfect metaphor for pride, downfall, and divine wrath. And in modern times, the torch passed to filmmakers. In cinema, comets and asteroids became shorthand for apocalypse. From the fiery spectacle of the 50s disaster reels to blockbusters like Armageddon and Deep Impact, the ancient fear found a new stage. Instead of medieval villagers cowering under fiery skies, we watched astronauts, presidents, and everyday people face the same question. What happens when the sky turns against us? What unites these works, paintings, poems, films, is not their accuracy, but their resonance. Comets became symbols of what we cannot control: judgment, destiny, the fragility of human power. The trail of light was more than physics, it was story, emotion, myth. It gave form to the anxieties that hum beneath every age, whether plagues in medieval Europe or nuclear fears in the 20th century. So when we turn our eyes to 3i Atlas and the imagination leaps to doom, we are not inventing something new. We are echoing centuries of artists who looked at the same blazing streak and painted it as a mirror of their fears. The comet, real or imagined, is not only in the sky, it is in us. From the earliest myths whispered around firelight to the pages of modern science fiction, humanity has always written the cosmos into its stories. Wandering stars, blazing comets, mysterious lights, they have never been just objects. They are metaphors, characters, symbols of our deepest fears and highest hopes. In literature, the sky becomes a mirror of the human soul. Ancient myths often cast comets and wandering bodies as omens or messengers. In Greek tradition, shooting stars were thought to be divine sparks, signals from the gods. The Norse spoke of fiery serpents slithering across the heavens as dragons of flame that foretold doom. In Mayan and Aztec cosmology, comets carried warnings of famine or war, their sudden appearance seen as cosmic punctuation in the story of human fate. As civilizations grew, so did the stories. Roman historians recorded comets at the deaths of emperors, folding them into the narrative of power and destiny. The Epic of Gilgamesh and other ancient texts describe celestial wanderers as signs of divine intervention, blending observation with myth. To the storytellers of antiquity, a streak in the sky was never meaningless. It demanded interpretation, and the interpretation demanded narrative. In later centuries, literature embraced the comet as a symbol of upheaval. Shakespeare used celestial portents to foreshadow tragedy. When beggars die, there are no comets seen. The heavens themselves blaze forth the death of princes. To Elizabethan audiences, this was not poetic flourish, but a reflection of belief that the sky itself wrote the script of human destiny. By the 19th century, as science began to strip away superstition, writers found new ways to use cosmic wanderers. Jules Verne imagined collisions with comets as grand adventures, while H.G. Wells explored catastrophe from above in apocalyptic visions that blended science with dread. The comet became not just omen but plot device, a trigger for human drama testing, whether society could survive when the heavens fell. Modern science fiction took the theme even further. Arthur C. Clarke and Isaac Asimov wove asteroids and interstellar objects into stories of exploration and survival. Films like Deep Impact and Armageddon echoed ancient myths in modern clothing, recasting the harbinger of doom as a CGI fireball streaking toward Earth. Even now, when a comet like 3I Atlas is discovered, social media fills with memes, jokes, and speculative fiction. The instinct to narrativize the unknown has never left us. What's remarkable is the continuity. From myth to Shakespeare, from Verne to Hollywood, the theme remains the same. Cosmic wanderers are never just rocks. They are symbols of destiny, of chaos, of endings and beginnings. The stories change, but the impulse is timeless. Whenever the sky gives us a mystery, we turn it into literature, into myth, into drama. So when you hear whispers of Atlas as an alien probe, or see novels spinning it into apocalyptic fiction, remember, this is what humans do. We turn cold stone into story. The cosmos sends us silence and we answer with words. In ancient times, comets spread fear slowly. A streak in the sky would be whispered by travelers, recorded by scribes, turned into rumor and legend as weeks and months passed. Today, the same streak can become a global obsession overnight. Fear, once carried by word of mouth, now spreads through memes, hashtags, and viral videos. When 3I Atlas was first reported, the news rippled across platforms like wildfire. Within hours, Twitter threads speculated about alien probes. YouTube videos with ominous titles racked up millions of views. TikTok creators stitched together dramatic music with AI-generated visuals of fiery impacts. Facebook groups churned out theories that governments were hiding the real threat. The science was clear: Atlas posed no danger. But in the social media age, clarity often drowns beneath spectacle. Memes gave the fear a playful mask. Pictures of Atlas captioned as Earth's new landlord, or the Death Star on holiday, circulated endlessly. People joked about paying rent to the incoming comet or packing bags for Mars. Behind the humour was something older, deeper, the same instinct that once made villagers in 1066 point to Halley's comet and murmur of doom. We dress fear in laughter, but the unease remains. Trending hashtags kept Atlas alive in public imagination long after the scientific news cycle moved on. For weeks, hashtag Comet Atlas and hashtag Alien Probe trended alongside politics and celebrity gossip. People shared dreams of fiery skies, anxieties about the future, or simply the thrill of being part of a conversation larger than themselves. The comet became less a scientific object than a cultural event, a symbol around which millions gathered in curiosity and fear. There is power in this connectivity. On one hand, it spreads misinformation, claims of impending impact, false warnings of cover-ups. On the other, it raises awareness, drawing attention to the broader issue of planetary defense. For every exaggerated headline, there was a thoughtful thread by an astronomer explaining what Atlas truly was. Social media amplifies both fear and knowledge, chaos and clarity, leaving each of us to choose which voice we listen to. In a sense, this is nothing new. Humans have always shared stories of the sky. The difference is speed. What once took months to reach a kingdom now takes seconds to reach the entire world. Fear now travels faster than light across screens and wonder with it. When Atlas passes harmlessly in 2025, billions will know about it not because they looked through telescopes, but because they scrolled. The social media age does not change our ancient reflexes, it magnifies them. The same instinct that made our ancestors see omens now makes us retweet memes. The comet has always been a story. The only difference is that now the story goes viral. Before 3I Atlas. Before Borisov, there was the one that first cracked open our imagination, Oumuamua. Discovered in October 2017 by astronomers in Hawaii, its name means scout or messenger from afar in Hawaiian, a fitting title for an object that seemed to arrive as a riddle from the stars. Unlike Atlas, Oumuamua was small, only a few hundred meters long, but its shape set it apart. Observations suggested it was highly elongated, like a cosmic cigar or perhaps a flattened shard. No comet or asteroid we had ever seen looked quite like it. Its brightness fluctuated wildly as though it were tumbling end over end, flashing sunlight in uneven rhythms. Scientists strained to model its spin, but even the best reconstructions left questions hanging. Then came its most puzzling trait, its motion. As it slipped past the sun, Oumuamua accelerated slightly, just enough to be noticed yet without the visible tail of gas that usually drives a comet's speed. It was as if something invisible pushed it a faint nudge against the laws we expected it to follow. Some argued it was outgassing, but no evidence appeared. Others wondered if it was something stranger, a fragment of a shattered world, a hydrogen iceberg, or whispered only, at first an artifact of design. Its reflective surface deepened the mystery. Oumuamua shone more brightly than expected, as if its skin were unusually smooth, perhaps metallic or icy. Combined with its odd trajectory and unexplained acceleration, these features made it the perfect canvas for speculation. Was it a shard of interstellar rock or a probe, a sailor messenger left adrift? Harvard's Avi Loeb famously argued for the latter, suggesting Oumuamua might be a fragment of alien technology, a discarded light sail perhaps propelled not by engines but by the faint pressure of starlight. Most of the scientific community pushed back, urging caution. Extraordinary claims, after all, demand extraordinary evidence. And Oumuamua gave us almost nothing to hold on to. It was too faint, too fast already on its way out by the time we found it. And yet the effect it left behind was profound. For the first time in living memory, humanity had seen a visitor from another star, and it refused to fit neatly into any box. Not asteroid, not comet, not entirely understood. It came silently, tumbled past and vanished into the dark, leaving only questions and a trail of wonder. Oumuamua taught us something essential, that the universe still holds mysteries close to its chest. And when Atlas appeared years later, larger and louder, it was measured against the shadow of that first strange messenger, the scout who came puzzled us and left without goodbye. When Oumuamua slipped past in 2017, it was like a whisper, small, faint, gone almost as soon as we noticed it. By contrast, 3i Atlas is a shout. Where Oumuamua was a shard, Atlas is a world. At nearly 46 kilometers across Anton, Atlas dwarfs its interstellar cousin 1,000 times over. To put that in perspective, if Oumuamua were a fragment of rock tossed into a pond, Atlas is an iceberg drifting across an ocean. Its sheer size alone makes it impossible to ignore. Unlike the fleeting speck of Oumuamua, Atlas lingers observable for years, giving us time to watch, measure and debate. And where Oumuamua was silent, leaving no cometary tail, no gas, no trace of chemistry, Atlas is alive with activity. It exhales carbon dioxide and cyanide, sheds nickel dust and glows with the faint signatures of complex molecules. Its behavior is more familiar to us and more comet than enigma. But within that familiarity lie puzzles, the absence of iron, the strange anti-tail, the improbable trajectory. Atlas is a contradiction, a comet that behaves almost like a comet, but not quite. The difference is not only in size and chemistry, but in presence. Oumuamua slipped by too fast for us to truly study. It was like spotting a stranger's silhouette in the dark. Atlas, on the other hand, gives us a closer look. With its broad comb-along tails and rich chemical voice, it offers data, thousands of reading spectra and images. Scientists can weigh it, map it, and trace its orbit back billions of years. For researchers, Atlas is not just a curiosity, it is an opportunity. And yet this clarity brings its own kind of unease. Oumuamua's mystery was its chance. Atlas's mystery is its volume, so many signals, some expected, some utterly alien to our models. It is not easily dismissed as a mere shard of ice. It is more like a moving micro-world, an interstellar planetesimal, that carries within it the fingerprints of a star system long gone. For the public imagination, this difference matters too. Oumuamua seemed too small to fear, too strange to comprehend. Atlas, by contrast, looks more like the threats we've been taught to picture in films, large, luminous, active, looming. Even though it poses no danger, its scale and brightness feed the narrative of doom. It is not a shadow passing quickly, but a mountain drifting steadily across our vision, impossible to ignore. In short, Oumuamua was the scout. Atlas is the Leviathan. Both remind us that the universe is not empty, but Atlas reminds us with a weight we can feel a presence less like an accidental shard and more like a frozen relic of another world wandering through ours. Oumuamua in 2017, Borisov in 2019, Atlas in 24, 3 interstellar visitors in less than a decade. The suddenness of these discoveries makes it tempting to believe the galaxy has only just begun sending guests to our doorstep, but the truth may be far simpler and far more humbling. They may have been passing by all along. We just didn't see them. For most of human history, we had no telescopes, no CCD cameras, no sky surveys scanning night after night with algorithmic precision. Our ancestors watched the heavens with the naked eye. They saw comets, yes, but only the brightest ones, blazing with tails tens of millions of miles long. Smaller visitors, silent stones, faint fragments, even dark giants would have swept past unseen. The Earth has likely always been a crossroads, where wanderers from other stars drift through and leave without a trace. Even in the modern era, our watch has been patchy. For decades, the sky was charted by a handful of observatories with narrow fields of view. An interstellar object the size of Oumuamua could easily slip past if it arrived sunward, or if it passed while surveys were offline. Only in the last 20 years have dedicated programs like Pan-STARRS, Catalina and Atlas begun to comb the sky systematically. Only now do we have algorithms tuned to notice the unusual arcs of interstellar trajectories. If so, then Atlas is not the third visitor, it is merely the third we've managed to catch. Others may have passed unseen during the Middle Ages, during the Roman Empire, even during the dawn of humanity. Imagine a comet sweeping overhead in the Ice Age, its faint tail unnoticed, except by a few hunters who looked up from their fires. Imagine a shard from another star drifting close during the Age of Pyramids, leaving no record because no one had the tools to distinguish it from an ordinary comet. This realization shifts the question. It is not. Why now, but why didn't we notice before? Perhaps interstellar wanderers have always threaded our skies, and only now with modern eyes do we recognize them for what they are. And if that is true, it suggests something profound: the galaxy is alive with traffic. Not spacecraft necessarily, but natural debris as fragments of ancient worlds ejected into the void, drifting endlessly from star to star. Some carry water, some carry organic molecules. Some may even carry the seeds of life itself. Each passing stone is not just an object, but a potential messenger from another sun whispering the story of a system we will never see. For millennia we have feared comets as omens of doom. Perhaps the real story is gentler. Perhaps these visitors have been brushing past us all along unnoticed, until now not as threats, but as reminders that the universe is vast, that we are not alone in its debris, and that every so often the stars send us a traveller from afar. Among all the sober calculations and cautious models, one idea hangs in the air like static before a storm. What if they are not natural at all? Harvard astronomer Avi Loeb has been the most outspoken voice for this possibility, suggesting that interstellar objects like Oumuamua and 3A Atlas might not be random fragments of stone, but something else, probes, seeds, or relics of alien technology. The argument begins with anomalies. Oumuamua accelerated without a visible tail of gas. Its shape was unlike any asteroid or comet we had catalogued. Atlas, meanwhile, moves on a path so statistically improbable that Loeb estimated its natural chance at just 0.05%. It exhales familiar chemicals, but with strange absences like iron stripped away. It carries an anti-tail more pronounced than expected. Each puzzle alone might be explained away. Together they form a question. Why assume randomness when intent cannot be ruled out? Loeb proposes that some interstellar visitors could be light sails, thin sheets designed to travel on the pressure of starlight. Others might be relics, ancient machines long dead drifting endlessly, their builders vanished into history. Some could even be seeds of panspermia deliberately or accidentally carrying the molecules of life across the galaxy. In this view, the Milky Way is not empty space, but an archive of attempts unworked, fragments of civilization, messages, or experiments scattered like dandelion seeds on the cosmic wind. Most of the scientific community is skeptical. The principle of Occam's razor urges simpler explanations. Comets, asteroids, chunks of rock behaving oddly because of forces we don't yet fully understand. To leap to alien probes risks tarnishing credibility. And yet history reminds us that science advances by daring questions. To dismiss the probe theory outright would be to close the door on possibility before it is tested. There is also a psychological dimension. The idea of alien relics fascinates us not only because it is extraordinary, but because it touches something deeply human, the fear of isolation and the hope that we are not alone. Each interstellar visitor becomes a mirror for our longing. Are we unique in the universe, or one chapter in a much larger story with other civilizations scattering breadcrumbs through the stars? Even if 3I Atlas is entirely natural, the probe theory forces us to think differently. to look at wanderers not just as ice and dust but as potential artifacts, to sharpen our instruments to search more carefully to ask questions we once reserved for myth and science fiction. The odds may be low, but the stakes are infinite, and perhaps that is the true power of Loeb's idea. Not that it proves anything now, but that it expands the frame. It reminds us that the next strange visitor could be more than stone. And if someday against all odds one of them is artificial, the greatest story in human history will begin with a faint dot in the sky and a question no one dared to ignore. For decades, scientists and dreamers alike have wrestled with the Fermi paradox, the simple, unsettling question, if intelligent life is common in the universe, why haven't we heard from it? The galaxy is old. The stars are countless. By probability alone, there should be civilizations among them. And yet the night sky is silent. Some call this silence the Great Filter, a barrier that life must pass but which few survive. Maybe most worlds never progress beyond microbes. Maybe civilizations destroy themselves before reaching the stars. Maybe spacefaring cultures become rare whispers rising and falling long before we have the chance to notice them. The filter could be behind us, or it could still loom ahead. And here is where 3i Atlas enters the imagination. What if objects like this are not just frozen relics of chemistry, but the whispers themselves? What if the silence of radio signals and absent starships does not mean absence of life, but a different kind of presence, quiet, patient, hidden in stone? The probe theory suggests that civilizations unable or unwilling to cross the stars in person might instead send their scouts disguised as comets, asteroids, or fragments of rock. A sea wrapped in ice drifting for billions of years, a machine camouflaged as rubble indistinguishable until examined closely, a relic with its purpose long forgotten, yet still wandering. If the galaxy is seeded with such messengers, then perhaps we are not alone, we are simply not listening in the right way. Of course there is no proof. Atlas could be nothing more than natural debris remarkable only for its size and trajectory. But even asking the question reframes the silence. Perhaps the universe is not mute but subtle. Perhaps what we mistake for randomness is pattern. What we call chaos is design. Perhaps the great filter is not the absence of others, but our blindness to their traces. This idea unsettles and comforts in equal measure. If Atlas is natural, we are reminded of our fragility in a universe of stone. If Atlas is artificial, then we are not the first to look up and wonder. Either way, the paradox remains. In a galaxy of billions, we are listening for voices, but may be deaf to whispers. And so as Atlas passes safely by in December 25, the question lingers in the dark. Was it only ice and dust, or was it part of a story older and stranger than we dare imagine? The silence of the stars endures, but sometimes silence is not emptiness. Sometimes it is waiting. The story of 3i Atlas does not unfold in silence. It sparks arguments, divides communities, and fuels late-night debates in observatories and lecture halls alike. On one side are the skeptics, the majority of astronomers who insist that Atlas, however unusual, is still a natural object. On the other are the believers, a smaller but passionate minority, who argue that its anomalies demand we keep the door open to more extraordinary explanations. The skeptics speak with the weight of science's cautious voice. They remind us that comets are unpredictable, that dust and gas behave in ways we do not fully understand, that statistical outliers are not impossible. They are inevitable in a universe of billions of objects. To them, Atlas is simply another comet with quirks magnified by our hunger for meaning. They caution against sensationalism, against mistaking ignorance for evidence, against turning science into story before the data is complete. The believers, however, are equally insistent. They point to the improbable trajectory, the absence of iron, the pronounced anti-tail, the sheer size that defies easy categorization. They argue that dismissing these mysteries outright is just as unscientific as jumping to conclusions. What if the anomalies are not noise but signal? What if Atlas, like Oumuamua, before it is a message disguised as stone? To them, shutting down the possibility of artificial origin is not caution, but blindness. The debate is not new. Science thrives in this tension between skepticism and imagination. One side demands rigor, the other insists on curiosity. Without skeptics, we drown in fantasy. Without believers, we miss the questions that lead to discovery. Atlas in this sense is more than a comet. It is a mirror of our scientific culture, reflecting the push and pull between certainty and wonder. For the public, the divide itself becomes part of the fascination. Headlines trumpet the bold claims of believers while burying the footnotes of skeptics. Social media amplifies the most dramatic voices, yet in quiet observatories, scientists on both sides still point their telescopes at Atlas, gathering data, watching, measuring, and arguing, not because they are divided, but because they are united by one truth: the cosmos still holds mysteries worth fighting over. And perhaps that is the most important point. Whether natural or artificial, whether relic or rock, Atlas demands attention. It forces us to question assumptions, to sharpen our tools, to widen our imagination. In that way, skeptics and believers are not opposites at all, but partners in the same endeavor, trying in their own ways to read the story written in the light of a wandering star. Science lives on a knife's edge between doubt and wonder. On one side lies skepticism, the relentless demand for proof, for replication, for evidence that can withstand every challenge. On the other lies imagination, the willingness to ask daring questions, to peer beyond the horizon of the known, to risk embarrassment in the pursuit of discovery. When objects like 3i Atlas appear, this balance is tested in full view of the world. Skepticism is the shield of knowledge. Without it, every anomaly becomes a fantasy, every unexplained detail proof of the extraordinary. Skepticism protects us from fooling ourselves, from mistaking noise for signal. It is what ensures that when science speaks, it speaks with authority, earned, not claimed. When most astronomers say Atlas is a natural comet, they are not dismissing mystery. They are defending a tradition of rigor that has carried us from superstition to understanding. But skepticism, unchecked, can harden into blindness. If we insist on only the expected, we risk ignoring the unexpected. If we close the door too firmly, we may miss the very discovery that could reshape our place in the cosmos. History is filled with examples: continental drift, once dismissed as fantasy, meteorites laughed off as stones from the sky, germs ridiculed as invisible nonsense. Each began as an idea too strange to fit existing models. Each became the foundation of new knowledge. This is where curiosity must enter balancing the scale. It dares to ask, what if it sees anomalies not only as errors but as opportunities? It entertains possibilities without demanding immediate belief. Imagination does not abandon rigor. It expands it. When Loeb suggests Atlas or Oumuamua might be artificial, he does not replace science with fantasy. He reminds us that skepticism must coexist with courage. The duty of science is not only to doubt but also to wonder. In the end, both sides are essential. Skepticism keeps us grounded. Imagination keeps us reaching. Together they ensure that science is neither rigid dogma nor reckless dream. The cosmos is vast, older than Earth, stranger than we yet understand. If we approach it with only skepticism, we will explain everything away. If we approach it with only imagination, we will believe everything we see. But if we approach it with both, we just might find the truth hidden in the light of a passing star. For all the debates for the math, the chemistry, the probabilities, and the theories, there is something about 3i Atlas that transcends the question of what it is. Whether comet or probe, whether natural relic or engineered seed, its presence in our sky gives us something no less profound: wonder. Wonder is the birthright of our species. It is what made our ancestors tilt their heads to the heavens and stitch stories into constellations. It is what carried Galileo to his telescope, what drove Newton to ask why an apple falls, what fuels every child who looks at the stars and asks what's out there. Atlas in its enormity rekindles that spark. Look at what it represents. A fragment older than Earth itself, drifting billions of years through the galaxy, crossing gulfs of darkness we can scarcely imagine. Its size alone dwarfs us. Its age humbles us. For once, humanity is reminded of scale, that our empires, our wars, our triumphs and failures are brief sparks in the life of a stone that has seen entire stars born and die. And yet instead of despair, this smallness can inspire. To know we are tiny is also to know we are rare. To know we are fleeting is to feel the urgency of our days. Atlas passes and reminds us that life, fragile and improbable, blooms here on Earth in defiance of cosmic indifference. That awareness is itself a kind of miracle. Even the act of naming Atlas is part of the gift. We take something vast and impersonal, and by giving it a name, we make it part of our story. It joins Halley's comet Oumuamua Borisov, a lineage of wanderers that remind us the universe is not static but alive with motion and encounter. Each new discovery widens the circle of our imagination. Perhaps Atlas carries no message. Perhaps it is only ice dust in chemistry, but the meaning we weave around it is not false, it is human. The awe it stirs is not a deception, it is truth, the kind that lives not in data but in the heart. And so whether natural or extraordinary Atlas has already fulfilled a purpose, it has reminded us to look up to, feel small, to feel curious, to feel alive. That is the gift of wonder. And in a universe where survival is uncertain, wonder may be as necessary as air. When we speak of 3i Atlas, of asteroids, of comets and cosmic wanderers, it is easy to lose ourselves in fear or fascination. But beneath those emotions lies something quieter, deeper humility. For Atlas is not only a story about what drifts through space, it is a story about us and how small we truly are. Earth is a fragile sphere barely 8,000 miles across, wrapped in a thin skin of atmosphere. To us it fills infinite continents, to cross oceans, to sail skies that seem without end. But from the perspective of the cosmos, Earth is a pebble, a grain of dust orbiting a middle-aged star in the suburbs of a spiral galaxy. And that grain is constantly swept by a storm of debris, asteroids, comets, meteors, fragments of creation that could at any moment remind us of our fragility. Yet within this fragile sphere, life persists. Against all odds, oceans form forests, breathe, civilizations rise, and children are born who one day lift their eyes to the very sky that could destroy them. The same randomness that hurls rocks across space also allowed this world to harbor water chemistry and the spark of consciousness. That tension between vulnerability and vitality is what makes our story so precious. Atlas underscores this truth. Its mass, its age, its journey through interstellar gulfs dwarf everything we know, and yet we are here to notice it, to give it a name, to tell its story. The irony is profound. We, the fragile, describe the eternal. We who measure our lives in decades study objects that measure theirs in billions of years. In doing so, we are reminded that survival is not guaranteed, that our place is not central, and that meaning is something we must create, not something the cosmos owes us. Humility, then, is not despair, it is clarity. To know that Earth is fragile is to value it more. Know that life is rare is to cherish it more. Know that we are small is to recognize that even small beings can create beauty, knowledge, and care. As Atlas drifts past, it does not bend its path for us. It does not notice us. But we notice it, and in that act we glimpse ourselves more clearly. The lesson is simple and eternal. We are tiny, but we matter. We spend so much time pointing our telescopes outward toward comets, asteroids, and interstellar wanderers that we rarely pause to imagine the reverse. What if someone somewhere is looking back? What would Earth look like to alien eyes drifting past at a distance of millions of miles? From afar, our planet would shine as a pale blue dot, delicate against the darkness. The oceans would glint, the clouds swirl, the continents shift in shades of green and brown. To a distant observer, Earth would be just another planet circling just another star. Small, ordinary, yet if they looked closer they might notice something remarkable, a strange imbalance in the atmosphere. Oxygen, carbon dioxide, methane, all present in unusual ratios. A chemical fingerprint that whispers life is here. Perhaps they would wonder what kind of life would they imagine: forests breathing, coral reefs blooming, migrations of birds and herds across the land. Would they guess at civilizations with cities glowing faintly in the night, a thin halo of satellites orbiting above radio signals spilling into the void? To them, these would be anomalies just as Atlas's chemistry is to us. Signs not of randomness but of intent. And what story would they tell of us? Would they see a species young and reckless, burning fuels, altering its climate, carving scars into its world? Would they see us as fragile dreamers, just beginning to look beyond our cradle? Or would they see us as a fleeting spark here for a moment in cosmic time, destined to vanish like so many before? It is humbling to realize that from another perspective we are the anomaly. We are the wanderer that does not fit the model. A world alive in a galaxy of silence. A civilization scattering faint signals across the stars, unaware if anyone listens. If alien astronomers debate us, perhaps their arguments mirror ours about Atlas. Some insisting Earth is just a natural world, others daring to believe it is more. This thought reshapes the question. While we wonder if Atlas could be a probe, someone else may be asking if Earth is a beacon. While we marvel at relics from other stars, someone else may be marveling at us. Perhaps the cosmos is full of watchers and storytellers, each peering across gulfs of space trying to read meaning in the faint glow of strangers. Atlas passes us by without looking. But if alien eyes linger on Earth, perhaps they see not just a planet, but a possibility. And perhaps the story they tell of us is the same one we tell of them. Are we alone, or are we simply waiting to be noticed? The universe is not young. It is nearly 14 billion years old, a span so vast that human history barely registers within it. Against that backdrop, Earth is a recent arrival, a stage lit only in the last third of the cosmic play. Our world has circled the sun for 4.5 billion years, and for most of that time it was silent oceans forming continents, drifting volcanoes erupting. Only in the last sliver did life bloom into something complex, and only in the last heartbeat did humans appear at writing their presence into stone story and sky. When we speak of 3i Atlas, we are reminded of this scale. Atlas may be more than 7 billion years old, older than our world, older than the sun itself. It carries with it a history we cannot touch, fragments of long-dead stars and forgotten systems. To stand on Earth and watch it pass is to witness the crossing of timelines, our brief, fragile moment intersecting with an object that has seen ages beyond counting. Civilization measures itself in centuries. Empires rise and fall in the span of a few hundred years. Even the pyramids are young compared to Atlas. The irony is humbling. We fight wars, build towers, launch rockets, all while drifting through a cosmos where billions of years pass in silence. To the universe, our achievements are as fleeting as sparks from a campfire in the wind. And yet fleeting does not mean meaningless. A play is not less profound because its scenes are short. Earth's role in the cosmic drama is unique. It is, as far as we know, the only place where matter has awakened to consciousness, where atoms born in stars have begun to ask questions of themselves. We are the storytellers of the universe, the part of creation that looks back at creation and wonders what it means. Placed on the cosmic stage, Earth is not grand in size or age, but in significance. Atlas reminds us of this contrast, a frozen wanderer carrying eternity in its bones, and us a species measuring time in breaths, yet capable of giving that eternity a voice. Perhaps this is the gift of perspective. To see ourselves not as rulers, but as participants. Not as the center, but as one fleeting actor in a play that stretches beyond imagination. The curtain will fall on us one day, as it has on countless species before, but in this moment, brief, fragile, luminous, we stand beneath the lights, aware of our place, aware of our stage. When a wanderer like 3i Atlas enters our skies, the true measure of humanity is not the rock itself, but how we respond. Do we greet it with fear, wrapping it in prophecy, and panic as our ancestors did with comets blazing over medieval kingdoms? Or do we meet it with curiosity, with instruments steady and questions open, determined to learn from whatever the universe sends our way? This is the quiet test of wisdom. Fear is natural. It has kept us alive through millennia of uncertainty. But unchecked fear narrows vision, blinds us to truth, and breeds paralysis. Curiosity, by contrast, is what has carried us from caves to cities, from fire to flight, from watching the stars to walking among them. When the cosmos presents us with a mystery, our choice between fear and curiosity is in many ways a choice between stagnation and survival. Atlas embodies this test. It is easy to see it as a harbinger of doom, to spread rumors of alien probes or hidden impacts, to let imagination spiral into dread. But it can also be seen as a teacher, a relic from another time, offering us knowledge about the galaxy's past, clues about the chemistry of distant systems, insight into the paths of creation itself. The same object can be omen or opportunity. The difference lies not in the stone, but in us. Throughout history, humanity has faced similar crossroads. A lightning strike could be seen as divine wrath or as the key to understanding electricity. A disease could be interpreted as a curse or as a puzzle to be solved by medicine. Each time our wisdom was tested by how we chose to frame the unknown. Fear kept us huddled. Curiosity moved us forward. The cosmos will continue to send us visitors. Some will pass harmlessly, some may threaten. But in each encounter, the greater danger is not the object itself. It is whether we let terror rule over inquiry. Wisdom lies in balance, respecting the risks but refusing to let them drown out wonder. So when we look at Atlas, perhaps the real question is not, what is it, but what will we make of it? Distraction or a discovery, a ghost or a guide? The answer will define us far more than the comet ever could. In the face of the unknown, humanity often divides into skeptics and believers, optimists and doomsayers, scientists and storytellers. But cosmic mysteries like 3i Atlas also hold the power to unite us, reminding us that beneath the borders, languages and conflicts, we all share the same fragile planet and the same endless skits. History has shown this before. When the Apollo missions carried humans to the moon, the image that moved the world most was not the astronaut standing on alien soil, but Earthrise our planet rising above the lunar horizon, a blue marble floating in darkness. For the first time, humanity saw itself whole without borders, without divisions. It was a vision of unity born from exploration. The International Space Station carries that spirit forward. Orbiting above us, it is a home built not by one nation but by many. Russia, the United States, Europe, Japan, Canada, all working together in a fragile partnership that endures even when politics on Earth fracture. The ISS is proof that cooperation in space is possible, even when it is difficult, even when trust is thin. And then there is Voyager, launched in 1977, still sailing beyond the reach of the sun's influence. On its side is the Golden Record, a time capsule of humanity music, greetings, the sound of waves and heartbeats meant not for one people but for anyone, anywhere who might find it. It is not the artifact of a single nation but of a species reaching outward. Voyager's journey belongs to all of us. 3i Atlas may never know it, but it joins this lineage. Its presence at Earth is a reminder that we are all passengers on the same planet, vulnerable to the same cosmic forces, staring at the same night sky. No matter where you live, beneath the glow of a city, under the sweep of the Milky Way, or in the silence of the desert, you look up and see the same wanderers pass overhead. The call to unity is not sentimental, it is survival. An asteroid does not care about borders, and neither should our defenses. To track the sky, to build watchtowers, to prepare for the stones that fall, we must act as one. Atlas in its grandeur whispers this truth. You are small, but together you are strong. In its passing, we glimpse not only our fragility, but our shared belonging. And perhaps that is the greatest gift these cosmic visitors bring. Not answers, but reminders that we face the questions together. When people whisper that 3i Atlas might be a probe, the question often points outward: who sent it? What does it mean? But sometimes the deeper reflection is inward. These speculations tell us as much about ourselves as they do about the object drifting past. In wondering whether Atlas is a machine, we hold up a mirror to our own hopes and fears. If we imagine it as a relic of alien technology, we reveal our longing not to be alone. We project into the silence the possibility that others have walked this road before us, that civilizations rise and fall across the galaxy, leaving fragments behind. The idea comforts us because if others reach the stars, perhaps we might too. If we imagine Atlas as a seed of panspermia carrying the ingredients of life across interstellar gulfs, we expose our hunger for connection. We yearn to believe that life is not an accident confined to Earth but part of a wider, older story. In picturing Atlas as a messenger, we are really expressing our desire to belong. And if we imagine it as a warning, a machine watching us, perhaps even judging us, we uncover our anxieties about our own power. We fear that others might look upon us as we look upon ourselves, with suspicion, with doubt, with the question of whether we are wise enough to survive. In this way, the idea of probes is not about aliens at all, but about humanity's reflection in the cosmic mirror. Throughout history, comets have been mirrors of culture. To the ancients, they foretold divine wrath. To Renaissance thinkers, they were portents of political upheaval. To the modern world, they are canvases for science and sometimes still for imagination. Atlas continues that tradition. Whether natural or artificial, it reflects back to us our longing, our fear, our wonder. Perhaps that is the true gift of these cosmic visitors. They remind us that meaning is not always in the stone itself, but in what we choose to see within it. The mirror is not out there, it is here in us. Atlas drifts on silent, indifferent. Yet in its passing, it becomes a story, a metaphor, a question. And in telling those stories, we come to understand not Atlas, but ourselves. The story of 3i Atlas is filled with awe and unease, its ancient age, its vast size, its strange chemistry, its improbable path. It is a reminder of both danger and wonder, of how fragile our place is, and how vast the universe remains. And yet for all its mystery, Atlas is passing us by harmless, indifferent. The future stretches on, filled with unknowns, but tonight that future can rest. The cosmos has always carried uncertainty. Rocks still wander unseen, stars still flare, black holes drift in silence. Our species cannot predict or control it all. But we are learning. We are building watchtowers, crafting defenses, telling stories that remind us not only of our fragility, but of our resilience. The future is not certain, but it is not hopeless either. It is a canvas vast and sleeping, waiting for us to paint upon it. Perhaps someday a true threat will appear, a rock not passing at a 68 million miles, but aimed directly at our world. When that day comes, the test of our wisdom, our unity, and our vigilance will matter. But that day is not today. Tonight, we are safe. The sky, though, filled with wanderers, offers us only sadin. And so as you close your eyes, let Atlas drift away in your imagination, not as a threat, but as a quiet companion, a reminder that time is long, that chance is real, and that life here and now is precious. The universe will continue its endless dance, comets and stars moving in rhythms older than Earth. We, for this brief moment, get to watch. Let the future sleep for now. The night is for rest. Tomorrow we may rise again to questions, to vigilance, to wonder. But tonight let the silence of the stars cradle you, as it has cradled life for billions of years. The sky holds its mysteries, and you hold the gift of rest. When three-eye Atlas blazes across our skies, we see it through the lens of telescopes, equations, and chemistry. But pause, and imagine what if ancient civilizations once saw visitors like this too? What if a wanderer from beyond the stars passed by in an age before glass lenses, before writing, before recorded science, leaving only myths of fiery serpents in the sky? Human history is threaded with strange tales of lights and omens. In Mesopotamia, clay tablets describe dragons of fire streaking across the heavens, twisting and coiling as if alive. The Norse sagas speak of Jörmungandr, the world serpent, rising from the sea to encircle the sky in flame. In Mesoamerica, Aztec priests feared the return of Xiuhcoatl, the serpent of fire, whose blazing tail was said to herald famine and war. Each story in its way resembles the glowing tails and writhing forms of comets. But could they also be echoes of something rarer, interstellar visitors passing unseen into myth? Consider the scale of time. Atlas has wandered the galaxy for billions of years. The odds say it cannot be the first to cross Earth's skies. Long before telescopes, long before mathematics, wanderers, like it must have swept past, seen not as comets catalogued, but as omens feared. Civilizations with no way to measure their orbits, no way to test their chemistry, could only do what humans always do: tell stories. They made sense of the unknown by clothing it in myth. And perhaps in those stories fragments of truth remain. A fiery dragon may be nothing more than a comet's twisting ion tail. A god's blazing sword may be the streak of an interstellar shard. A serpent devouring the world may be the shadow of a passing wanderer, glimpsed with terror, retold in ritual and legend. To us these myths are metaphors. To them they were memory. The shadow of lost civilizations lingers in these tales. Most of their knowledge has gone washed away by floods of time, but their fear, their awe, their instinct to connect sky to story remains. And in that instinct they were not so different from us. When we wonder if Atlas is a probe or a sign or an omen, we are continuing the same ancient reflex, turning silence into meaning. Perhaps one day another civilization will look back at our stories, at our whispered debates about Atlas, and see in them what we see in ancient myths, not proof but echoes. A reminder that across millennia the sky has always been a mirror for human imagination, and that every generation leaves its own legends of fiery wanderers. Long before three-eye Atlas, before Oumuamua, before telescopes turned the heavens into charts and numbers, humanity encountered wanderers in another way through story. The sudden blaze of a comet in the night sky was never neutral. It demanded explanation. And so cultures wove these fiery visitors into their myths, turning fleeting astronomical events into timeless memory. In the Norse sagas, the sky often split open with fire. Jörmungandr, the world serpent, was said to rise at the end of days, spitting flame across the heavens before Ragnarok consumed the world. Some scholars believe this imagery of serpents in the sky, of world-ending fire, echoes memories of comets blazing long tails, twisting, like living creatures above terrified villages. In their fiery trails, the Norse saw prophecy, a reminder that the world could end not only by war but by the heavens themselves. In Chinese chronicles, comets were catalogued with meticulous care. Astronomers kept records stretching back over 2 millennia, noting the colour, shape and direction of each broom star. These appearances were often tied to dynastic change or natural disaster. A comet might signal the fall of an emperor, or the rise of rebellion, or the approach of famine. For the Chinese, comets were not random. They were part of the moral fabric of the universe, reminders that the heavens and earth were bound in harmony. When the skies broke pattern, it was a warning that the world below was breaking too. In Mayan tradition, comets and blazing stars were often linked to drought, war, and upheaval. The Dresden Codex, one of the few surviving Mayan manuscripts, contains imagery of celestial serpents spitting streams of flame and water. These depictions may be stylized records of comets remembered as bringers of imbalance. To the Maya, such visitors were woven into cycles of time folded into their cosmic calendar, as harbingers of endings and beginnings. Across these cultures a pattern emerges. Wherever comets appeared, they became cultural memory recorded in tapestry carved in stone inked in scrolls. They became metaphors of destruction, transformation, renewal. And while these ancient peoples did not know orbital mechanics or galactic history, their instincts were not entirely wrong. Comets are indeed messengers of change. They bring water molecules chaos. They have ended dynasties not through prophecy but through impact. When we look at Atlas today, we bring our own cultural memory to it. We whisper of alien probes, we craft viral memes, we spin speculative documentaries. In this we are no different from the Norse, the Chinese, the Maya. We take the unknown in the sky and weave it into the fabric of meaning. Atlas joins the long tradition of wanderers that shape not only science but story. And perhaps that is why these myths endure, because they remind us that across cultures, across centuries, the sudden appearance of a cosmic visitor has always been a mirror of fear, of hope, of mortality. Interstellar objects are not only astronomical, they are cultural, written in memory as much as in mathematics. 3R, Atlas, is not only a mystery to ponder, it's a laboratory in motion. Every reading we take, every spectrum we analyze, every calculation of its speed and trajectory offers technological lessons that could shape humanity's future in space. Beyond awe, beyond fear, Atlas is also a teacher. The first lesson lies in propulsion. Atlas streaks through the solar system at nearly 30,000 miles per hour, guided only by gravity and the chemistry of its own sublimating gases. By studying how sunlight nudges its dust, how gases vent to shift its path, we gain insight into natural propulsion systems. Future spacecraft might mimic these processes using sails vents or controlled outgassing to move without fuel. In the way Atlas drifts, we glimpse the possibility of long-term low-energy travel across the stars. The second lesson lies in composition. James Webb and ground-based telescopes detect Atlas's breath, carbon dioxide, cyanide, nickel, dust, but oddly no iron. These clues tell us about the chemistry of other star systems, about the ingredients that shape their planets and perhaps their life. They also tell us what resources may lie within comets and asteroids. For a civilization reaching into the solar system, such knowledge is not abstract, it is practical. Water ice becomes fuel, metals become construction, organic molecules become raw material for life support. What looks like a drifting relic could one day be a mine, a wellspring, a stepping stone to the stars. The third lesson is about survivability. Atlas has endured billions of years in interstellar space. Radiation collisions, gravity, all have failed to erase it. Understanding why some objects survive while others break apart teaches us not only about cosmic geology, but about how to design spacecraft meant to endure similar journeys. If Atlas can survive 7 billion years, perhaps we can learn to build machines, or even habitats that echo its resilience. Already, visionaries speak of asteroid mining, of colonies supplied by icy rocks, of spacecraft refueling at comet wells. Atlas is not a resource we can reach, it is too far too fast. But it is a model of what lies waiting closer to home. Its chemistry, its stability, its sheer scale remind us that the cosmos is not only danger but opportunity. The same stones that can threaten us can also sustain us if we learn their language. And so in studying Atlas, we are not only deciphering a wanderer, we are writing a manual for our future. Propulsion, resources, survival. Each fragment of data is a lesson, each orbit a clue. The stone drifts on indifferent, but for those watching below, it may carry the keys to the next chapter of human expansion. 3I Atlas is not the last wanderer we will see. It is a reminder, even a promise, that the galaxy will continue to send us fragments from afar. And if the past decade has taught us anything from Oumuamua in 2017 to Borisov in 2019 to Atlas today, it is that we must be ready. The age of interstellar discovery has begun, and our tools must grow with it. The first frontier lies in new telescopes. The Vera C. Rubin Observatory in Chile, set to begin full surveys, soon will scan the entire visible sky every few nights, capturing faint movers that would once have gone unseen. Infrared missions like NeoSurveyor will extend our reach, revealing dark objects hidden in the glare of the sun. Together they will ensure that the next Oumuamua does not slip by unnoticed, that the next Atlas is tracked from its first breath of sunlight. The second frontier is artificial intelligence. Our sky surveys generate oceans of data terabytes every night, millions of points of light to sift through. Hidden within them may be the subtle arc of an interstellar visitor. AI algorithms trained to spot unusual trajectories are already transforming discovery rates. What once required months of human labor can now be done in hours. The next object may be flagged by a machine before a human eye ever sees it, proving that our future watchtowers will not only be telescopes but neural networks. The third frontier is mission design. DART showed we can strike an asteroid. Hera will show us how the aftermath unfolds. But future missions may go further, designed not to deflect but to chase. Imagine spacecraft held in readiness, able to launch within months and intercept the next interstellar visitor. They would not only image the object but sample it, perhaps even return fragments to Earth. For the first time we would hold in our hands material born under another star. The final frontier is international vision. Just as no nation can defend against asteroids alone, no nation can study interstellar visitors in isolation. Shared data, joint missions, consecutive funding, these will be the foundation of the science to come. Atlas may belong to no one, but the knowledge it offers belongs to all of us. The future of interstellar study is not just about science, it is about identity. Every visitor we track, every spectrum we analyze, every probe we send expands the boundary of what it means to be human. We are no longer creatures bound to Earth, but participants in a galactic conversation written in stone and ice. And so as Atlas drifts into darkness, we prepare not for its return, but for the next messenger. Somewhere out there another fragment is already on its way. When it arrives, we will be ready to watch, to learn, to wonder. Imagine just for a moment that 3i Atlas was not natural. Imagine instruments revealed circuitry hidden beneath ice, a structure too precise for chance, a design too deliberate for geology. Humanity would then face not only discovery but a dilemma: should we answer or remain silent? This is the essence of the dark forest theory, a haunting vision of the galaxy. In it, every civilization is a hunter, moving quietly through a forest, careful not to reveal itself. For in the dark, one cannot know if the other hunter is friend or foe. To call out to light a fire is to risk destruction. Survival in this metaphor depends on science. If Atlas is a probe, is it wise to whisper back? Some argue yes. To respond would be to announce ourselves as part of a greater community, to take our place among civilizations older and wiser than our own. Perhaps the probe is not a hunter, but a messenger waiting for us to speak, to join a conversation already spanning the stars. To stay silent would be to miss an invitation written across billions of years. Others urge caution. History on Earth shows that when civilizations of unequal power meet, the outcome is rarely gentle. Contact often brings conquest, exploitation, or erasure. If Atlas were truly artificial, we could not know its maker's intent or whether they still exist at all. To reply blindly would be to gamble with the only world we have. And then there is a third possibility, that silence itself is the answer. Perhaps probes like Atlas are not meant to be triggered by signals, but by patience. They might be archive seeds or warnings carrying meaning in their presence alone. In this view, the dilemma is not whether to respond, but how to interpret. Maybe the universe does not speak in words, but in wanderers. The truth is, we don't know, and that uncertainty is the heart of the dilemma. If Atlas were artificial, humanity would be forced to decide: risk communication or embrace silence. Either choice would define our species for millennia to come. And so for now, the question remains hypothetical. Atlas shows no signs of artifice, only the silent chemistry of ice and stone. Yet by stirring the question, it prepares us. It forces us to ask not only what is out there, but who are we and how do we wish to be known? Curiosity is humanity's greatest gift and its greatest temptation. Every advance we've made has begun with a question, a risk, a step into the unknown. Yet history also warns us that curiosity unchecked can bring ruin as easily as progress. 3i Atlas. Drifting silently past our world becomes not only a subject of study, but a mirror of this eternal dilemma. How far should we reach and when should we hold back? The ancients told this story long before telescopes. In Greek myth, Prometheus defied the gods to steal fire, giving humanity the power of warmth and light, but also the tools of war. His gift transformed civilization, yet carried with it unending suffering. Curiosity brought survival, but also punishment. In the same tradition comes Pandora, who opened her forbidden jar out of wonder, releasing every misery into the world, plague, hunger, sorrow leaving only hope at the bottom. Exploration and caution, light and shadow, always twined together. Science continues this paradox. To study Atlas, to dream of intercepting such objects, is to expand our understanding of the galaxy. Each measurement deepens our knowledge of chemistry, motion, and origin. Each speculation pushes us toward new tools and new missions. But to push too quickly, to assume too much, risks missteps. If Atlas, or one like it, were more than ice and stone, would we have the wisdom to know how to respond? Or would curiosity open a jar we cannot close? The ethics of curiosity is not about rejecting exploration, it is about balance. We must dare enough to grow, but not so recklessly that we stumble into danger unprepared. Every probe launched, every telescope built, every signal sent into space carries with it both promise and peril. The decision is not purely scientific, it's philosophical, moral, deeply human. Atlas reminds us of this balance. It tempts us to speculate wildly, to weave stories of alien craft. It also reminds us to measure carefully, to stay so grounded in data. To be curious is essential. To be cautious is survival. The two must walk together as they always have since Prometheus stole fire and Pandora opened her jar. And perhaps this is the lesson. Curiosity is not the enemy, it is our defining trait. But curiosity without humility is hubris, and hubris has always been humanity's downfall. If we can learn to temper wonder with wisdom, exploration with restraint, then the next interstellar visitor will not only be a subject of science, but a chapter in a story where curiosity leads not to ruin, but to light. Long before 3i Atlas crossed our skies, long before Earth was even born, the matter that would become us was already wandering the galaxy. Hydrogen from the first star's carbon from ancient supernovas, iron forged in the collapse of giants, all of it scattered, drifting, waiting. From that chaos came the solar system. From that solar system came Earth. And from Earth came us fragile, curious, conscious. We are in every sense children of the stars. Every atom in our bodies tells this story. The calcium in our bones was born in the heart of a massive star. The oxygen in our lungs was woven in stellar furnaces. The carbon that shapes our cells was cast off in explosions that tore suns apart. We are not separate from the universe. We are its continuation, its voice, its way of looking back at itself. When we gaze at Atlas, we are not outsiders observing an alien object. We are family recognizing family. Its dust is our dust. Its metals are our metals. Its molecules echo those that seeded Earth with the chemistry of life. In studying it, we study our own ancestry, the raw material that under the right conditions became oceans, forests, animals, and eventually us. This is why awe runs so deep when we speak of wanderers like Atlas. They remind us that we are not accidents sealed off on a lonely world. We are participants in a much older story written across the galaxy in drifting stone and flame. The universe is not above us, it is within us. And when we look up, we are really looking back at our own origins. To call ourselves children of the stars is not poetry, it's physics. Yet in that physics lies meaning. For if we are born of stardust, then the stars are not strangers, they are kin. And our curiosity to reach them, to explore them, to send our machines and our questions into the void is not ambition alone, it is nostalgia. A longing to return to the place we began. Atlas will continue on its path carrying stardust from another system, a reminder that the galaxy is alive with fragments of creation. We, the stardust that learn to speak, will watch it pass. And in that moment the circle closes, the universe aware of itself, marveling at its own reflection. For all the grandeur of 3i Atlas, for the billions of years it has drifted, for the questions it has stirred, for the fears and hopes it has awakened, it is easy to forget the simplest truth. Life continues tomorrow. The comet will pass, the stars will shine, and here on Earth the rhythm of ordinary days will unfold. The baker will rise early to knead bread. Children will laugh in playgrounds. Farmers will walk their fields watching the seasons turn. Friends will share meals. Lovers will share silence and ambulances. Families will argue and reconcile, and countless small acts of living will continue beneath the same sky that carries Atlas on its journey. This is the quiet resolve of humanity. We do not live suspended in cosmic dread waiting for rocks to fall. We live in the texture of the everyday, in the warmth of a cup of tea, in the sound of footsteps on familiar streets, in the comfort of voices we know. These ordinary joys are not distractions from the cosmos. They are what make survival worthwhile. Atlas reminds us of our fragility, yes, but also of our resilience. We can stare into the immensity of the galaxy and still return to the small luminous moments that define our lives. The universe may be vast and time may be long, but meaning is made here in the fleeting breath of today. So let Atlas drift. Let the debates continue, the theories swirl, the data be passed. Meanwhile, life persists. Tomorrow you will wake, eat, work, laugh, rest. The cosmos may not notice, but you will. And that is enough. In the face of taunts, in the shadow of wandering giants, humanity endures not only with science and vigilance, but with ordinary joy. That is our quiet resolve. Lessons from a wandering star. When 3i Atlas swept into our solar system, it brought with it more than frozen gases and fragments of ancient stars. It brought perspective. In its silence, its enormity and its mystery, Atlas became not just an object of science, but a mirror reminding us of what it means to be human in a universe far older and vaster than ourselves. The first lesson is humility. Atlas is older than Earth, forged in the galaxy's youth billions of years before our planet formed. To see it glide past reminds us how fleeting human history is. Empires, inventions, wars and triumphs, all of them are sparks compared to the slow arc of a comet's journey. Recognizing our smallness does not diminish us. It sharpens our gratitude for the fragile life we hold. The second lesson is curiosity. Throughout history, humans have looked at comets and seen omens, serpent swords in the sky. Today we have telescopes and data instead of myths, but the instinct is the same, to make meaning out of mystery. Curiosity has always been our answer to fear. When we ask what is it instead of hiding from the unknown, we turn dread into discovery. The lesson of Atlas is that fear narrows the world, but curiosity expands it. The third lesson is vigilance. Atlas itself is harmless, but countless smaller rocks wander nearby. The Chelyabinsk meteor in 2013 injured over 1,000 people with no warning at all. Our survival depends on watchfulness on telescopes, satellites, and the collective will to keep our eyes on the sky. Vigilance is not paranoia, it is responsibility. It reminds us that protecting what we love requires patience and discipline, even when the danger feels distant. The fourth lesson is unity. An asteroid does not care about borders. A cosmic threat, should it ever come, would face us as one species, not as nations. Atlas reminds us that cooperation is not a luxury, but a necessity. The same spirit that built the International Space Station that sent Voyager into the deep must be the spirit that guides planetary defense, and perhaps one day interstellar exploration. The fifth lesson is wonder. Beyond statistics and survival, Atlas inspires awe. To know that we are made of the same stardust, that our atoms were born in ancient stars just as Atlas was, is to recognize that we are connected to the universe in the most intimate way. Wonder keeps us alive in a different sense. It gives us purpose, meaning, and joy. In the end, Atlas is not just a comet. It is a teacher. It shows us humility in our smallness, curiosity in our questioning, vigilance in our watchfulness, unity in our shared sky, and wonder in our belonging. These are not abstract cosmic lessons. They are guides for daily life, reminders to stay humble, to stay curious, to remain watchful, to work together, and to let awe soften our days. The comet will pass, life will continue, and beneath the stars so will we. And now as Atlas drifts onward into the deep and as the night wraps itself around you, let the story quiet. The questions can wait. The debates, the data, the mysteries, they belong to tomorrow. Tonight belongs only to calm. Close your eyes and imagine the sky above you. Stars like silver dust spread across a canvas of velvet. Somewhere out there, Atlas glides on its ancient path, indifferent, yet luminous, a relic of times before Earth was born. You do not need to solve it. You do not need to hold its secrets. It is enough to know it is there, moving, whispering, its silent song across the cosmos. Feel the stillness now. Let your breath slow, rising and falling like the tide, like the orbit of a planet, like the drift of a comet through the dark. You are safe here, a child of the stars, resting under their endless watch. Thank you for keeping company in this journey through science, through myth, through speculation and wonder. Thank you for letting curiosity carry you across galaxies and back home again. And now let curiosity soften into rest. The universe is vast and time is long. But tonight all you need is this moment. Let the stars guard your sleep. Let the silence hold you gently, and let awe be the last thought you carry into dreams. Good night.